Our closest galactic neighbor holds secrets that rewrite reality. The Andromeda Galaxy is a mirror to our own Milky Way, a vast spiral of stars just 2.5 million light-years away. But within its swirling arms and brilliant core, astronomers have found anomalies that defy every expectation. We are about to embark on a journey to uncover 40 of the most bizarre objects ever detected in another galaxy. By the end, you will know the location of potential alien megastructures, stars that challenge the laws of physics, and cosmic signals that have no logical explanation. We will see a star that orbits backwards and a planet that glows with impossible light. What do you believe is waiting for us in the dark? The first object on our list is not a star, a planet, or a nebula. It is a single point of light with a secret. Astronomers call it the Andromeda Parallax Anomaly. Parallax is how we measure cosmic distances. Hold your thumb up and close one eye, then switch to the other. Your thumb appears to jump against the background. That is parallax. We do the same with stars, observing them from opposite sides of Earth's orbit around the Sun. The tiny shift in their position tells us how far away they are. Every star in the Andromeda Galaxy should show an identical, minuscule parallax shift because they are all roughly the same immense distance from us. But one point does not. This solitary speck of light shows a different, slightly larger shift. This is impossible if it is truly part of Andromeda. The math suggests it is not 2.5 million light-years away. It suggests this object could be within our own solar system, perhaps just a few hundred astronomical units out in the cold dark. Think about that for a moment. A watchtower, silent and ancient, floating in the void between the Sun and the Oort cloud. Fringe theories propose exactly that, a monitoring station built by an advanced intelligence. Its perfect location would offer a grand, unobstructed view of two galaxies, our Milky Way and the Great Spiral of Andromeda. It could be a sentinel, observing the development of life here while keeping an eye on its home galaxy. The scientific response has been intense scrutiny. Researchers have pointed every available instrument at this anomaly, conducting deep spectral analysis to read its chemical fingerprint. The results are confusing, a jumbled signature that does not clearly match any known object, natural or artificial. It refuses to be easily categorized. Is it a strange, fast-moving comet or asteroid with highly unusual composition? Or is it something else entirely, something placed there on purpose? The Andromeda Parallax Anomaly remains a quiet, persistent question mark in our telescopes, a mystery that begins our journey not in the distant galaxy, but potentially right in our own cosmic backyard. That strange chemical fingerprint is where the mystery deepens into a full-blown spectral puzzle. When astronomers break starlight into its component colors, they create a spectrum, a unique barcode that reveals the object's composition, temperature, and motion. The spectrum of the parallax anomaly is a confusing mess of lines that simply should not exist together. It shows the faint, cool signature you might expect from a failed star, a brown dwarf, but superimposed on that are sharp, intense emission lines for elements like technetium. Technetium is highly unstable on Earth, with all its forms decaying radioactively in just a few million years. Finding it in a natural object implies some continuous, ongoing process is creating it, a process we do not fully understand. Even more puzzling are broad, smeared absorption bands that some researchers have cautiously likened to the theoretical spectral residue of certain advanced propulsion concepts, a kind of cosmic exhaust plume frozen in the light. The key observatories on the case read like a who is who of modern astronomy. The Hubble Space Telescope first pinpointed the anomaly's odd parallax. The Keck Observatory in Hawaii and the Very Large Telescope in Chile have spent countless hours collecting its faint light, trying to decode its spectrum. Each new observation seems to add more questions than answers. The scientific debate is fierce and ongoing. One camp argues this must be an exceptionally strange type of sub-brown dwarf, a rogue planetary object with an atmosphere churned by unknown chemistry, perhaps rich in rare, heavy elements from a long-ago cataclysm. Another, more speculative group points to the technetium and the unusual line shapes, whispering about the possibility of artifacts, of materials engineered for purposes we cannot fathom. They ask, could the spectral mess be because we are not looking at a natural object surface, but at the complex, layered signature of something constructed? This solitary point of light, whether a freak of nature or a silent monument, holds its secrets tightly. Its very light is a language we are only beginning to learn how to read. The spectral confusion of our first anomaly gives way to a different kind of cosmic whisper, one written not in visible light but in heat. Deep within Andromeda's vast disk, the Spitzer Space Telescope once locked onto a brilliant, pinpoint source of infrared radiation, catalogued as M31 UIRS1. Infrared is the language of warmth, the hidden glow of objects too cool to shine in visible light. This source was not just warm, it was blazing. For a brief period, it outshone entire star clusters in its specific infrared band, a sudden and ferocious beacon of heat in the cold dark. Yet when astronomers pointed optical telescopes at that exact coordinate, they saw nothing. No star, no nebula, no visible cataclysm. It was a ghost visible only by the heat it left behind. Such intense, isolated infrared bursts typically have only a few explanations. One is a dust-enshrouded young star, a stellar nursery hiding its brilliant newborn sun behind thick clouds of cosmic dust that absorb its light and re-radiate it as heat. Another is the furious heart of an active galactic nucleus, where a supermassive black hole feeds and unleashes incredible energy, but M31 UIRS1 fits neither. It was not in a known star-forming region, and it was transient, flaring up and then fading over a period of months, something a galactic core or a newborn star would not do. This leaves a profound puzzle. What event can produce a sudden, titanic release of heat without the accompanying flash of visible light or the lingering structure of a nebula? Theorists looking for answers have ventured into extraordinary possibilities. One compelling idea is that we witnessed the aftermath of a colossal engineering project, a signature written in waste heat. Imagine a civilization beginning to construct a Dyson sphere, a hypothetical megastructure designed to encapsulate a star and harvest nearly all its energy. The initial stages would involve dismantling planets, processing unimaginable amounts of material, and redirecting stellar output. These processes would generate staggering amounts of infrared radiation as a byproduct, a thermal signature of industry on a galactic scale. The transient nature of the flare could mark the peak of that construction phase, after which the structure becomes more efficient and its thermal signature drops. An even more dramatic theory suggests we saw the catastrophic conclusion of an asteroid mining operation of inconceivable magnitude. Picture not a single ship, but a swarm of machines systematically dismantling a large moon or a dwarf planet, perhaps to acquire raw materials for those same megastructures. If something went wrong, if the entire operation triggered a runaway reaction or a massive collision, the resulting energy release could vaporize the target body in a flash, creating a brief, intense cloud of hot debris that glows fiercely in infrared before dissipating into the void. The event would leave no visible remnant, just a fading heat signature and a missing celestial body. Whether it is the birth of a megastructure or the death of a world, M31 UIRS1 stands as a silent testament to a sudden, powerful, and deeply mysterious release of energy, a thermal scream from the dark that we are still struggling to interpret. That fading thermal signature leaves us with a question about absence, a question answered in the most dramatic way possible by our next object. Between the glittering star clouds of one of Andromeda's majestic spiral arms, there exists a profound nothing. Astronomers call it the Great Andromeda Void, Picture a spiral arm not as a solid ribbon, but as a bustling cosmic highway, thick with stars, nebulae, and star clusters. Now imagine a stretch of that highway, hundreds of light years long, where the traffic simply vanishes. The stellar density here plummets to almost zero. It is not a small, dark nebula blocking our view. It is a genuine, gaping hole in the galactic fabric. Finding such an empty region in the midst of a star-forming spiral arm is like discovering a perfectly circular lake in the middle of a dense, old-growth forest, a lake with no water, just bare, empty earth. It defies the natural architecture of a galaxy, so what could carve out such a colossal cavity? The leading natural explanation is a chain reaction of stellar violence. Supermassive stars live fast and die young, exploding as supernova. The shock waves from these blasts can sweep up surrounding gas and dust, pushing it outward and clearing a region, even triggering new star formation at the edges. It is possible that a cluster of these stellar giants was born long ago in this spot. One by one, they exploded, their collective fury scouring the area clean of the raw materials needed to make new stars. The result would be a bubble, an old, sterile wound in the arm. Yet the scale of the Great Void gives even this dramatic explanation pause. The energy required to create and maintain such emptiness across centuries is staggering. This has led to a far more profound and unsettling hypothesis. A Kardashev Type 3 civilization is one that has harnessed the total energy output of its entire galaxy. Such a civilization would not build Dyson spheres around single stars. It would dismantle stars themselves, using their material and energy for purposes beyond our comprehension. The Great Andromeda Void, some theorists suggest, could be the evidence of such a project, a region where every star, every planet, every speck of usable matter has been systematically harvested. It would be a completed construction site, a cleared lot on a galactic scale, leaving behind only a chilling emptiness. Astronomers are desperately searching for clues in the void itself. They scan for the faintest whisper of hydrogen gas, the residual heat of long-cooled stellar ash, or the subtle gravitational tug of dark matter, anything that could tell the story of what was once there and how it was removed. The silence from that region is in its own way louder than any signal. Is it the echo of ancient natural cataclysms, or is it the signature of a universe being actively, intelligently rearranged? The silence of a galactic void is one extreme, but a crowded ball of ancient stars presents a mystery of its own. Orbiting the Andromeda Galaxy is a globular cluster known as METE-01. Globular clusters are dense, spherical swarms of hundreds of thousands of stars, all born together in the early universe. They are cosmic retirement homes filled with old, cool, red stars. METE-01 fits this description except for one glaring anomaly. Scattered throughout its ancient core are dozens of brilliant, hot blue stars. Astronomers call these outliers blue stragglers. They appear straggling behind in the aging process, looking billions of years younger than their neighbors. In a place where all star formation ceased eons ago, their presence is a profound puzzle. The standard explanation is stellar cannibalism. In the crowded core of a globular cluster, stars can pass dangerously close to one another. Sometimes, two older stars will collide and merge, creating a single, more massive, hotter, and bluer star from the combined fuel of its predecessors. Alternatively, a hungry white dwarf star in a binary system can siphon material from its companion, reigniting nuclear fusion on its surface and creating a blue, youthful facade. These are violent, natural processes that do create blue stragglers in many clusters. But METE-01 is an outlier among outliers. The number of blue stragglers in its core is not just high, it is statistically bizarre, a dense concentration of stellar rejuvenation that seems too efficient to be random. Furthermore, this cluster moves with a peculiar velocity, tracing an orbit around Andromeda that is slightly inclined and faster than models predict. as if it were a foreign object, a captured intruder with a strange history. This combination of traits has sparked a more speculative line of inquiry. Could we be looking at signs of ancient stellar engineering? Imagine a civilization that achieves mastery over gravity and matter. For such a culture, stars are not just distant lights, they are power plants. The process of merging stars, of carefully combining smaller, cooler stars to create newer, hotter, and more energetic ones, could be a form of cosmic infrastructure. A cluster like MATEO1 with its dense stellar population would be a perfect resource hub. Each blue straggler could represent a reactivated power source, a beacon for navigation across vast intergalactic distances, or even a monument. The cluster's unusual motion could then be explained not as a natural capture, but as a deliberate parking orbit, a chosen location for this grand project. While mainstream astronomy continues to model complex collision scenarios to explain the blue straggler population, the idea lingers. Are we seeing the aftermath of a natural, if spectacular, series of stellar crashes? Or are we witnessing the fossilized remains of an energy grid where stars were not born but were made? The quiet industry of stellar engineering pales before a signal that briefly screamed across the galaxy. Deep in the archives of radio astronomy lies a record of a single bizarre event. It was catalogued as the Transient Radio Ring 1 (TRR1) during a routine low-frequency survey of Andromeda. A perfect, ghostly circle of radio waves materialized on the data readout. This was not a blurry smudge or an irregular cloud. It was a ring of astonishing geometric precision, hanging in space like a cosmic bullseye. For several months, this silent siren blared its radio frequency song, and then, as mysteriously as it arrived, it faded into the background noise, never to be seen again. The most unsettling feature was what lay at its center: absolutely nothing. There was no pulsar, no black hole, no visible star or remnant to serve as the engine for such a symmetrical structure. It was a ripple without a stone, an echo without a source. Natural astrophysics scrambles to explain such a phenomenon. One compelling theory points to an event so rare we have never confirmed it in our own galaxy, a quark nova. Imagine a neutron star, the ultra-dense corpse of a giant star, collapsing under its own gravity one step further. Its very protons and neutrons might dissolve into a soup of their constituent particles, quarks, releasing a catastrophic spherical shockwave. This wave, expanding at a significant fraction of light speed, would energize the interstellar medium around it, causing a shell of gas to glow in radio waves for a time before dissipating. The ring we saw would be a two-dimensional slice through that three-dimensional bubble. Another idea is an echo from the distant past, the remnant shell of a gamma-ray burst that occurred millennia ago, its lethal jet long gone, but its slower-moving shockwave finally reaching a patch of gas dense enough to light up in radio frequencies for our instruments to catch. Yet the ring's perfection and its solitary, one-time nature invite more profound questions. What if we witnessed a form of communication, but not one meant for us? A civilization capable of harnessing galactic energies might not use narrow-beam radio signals. Instead, they might send a galaxy-wide ping, a single, omnidirectional pulse of immense power designed to announce their presence or synchronize some vast, distributed network. The ring would be that pulse, frozen in time as it illuminated a shell of interstellar gas on its journey outward. An even more staggering possibility involves the fabric of spacetime itself. Theoretical physics allows for shortcuts through the cosmos called wormholes, but stabilizing one would require energies beyond comprehension and would likely produce massive, radiating effects. Could the transient radio ring have been the brief, visible stabilization signature of such a structure, a throat being held open for a cosmic instant before it collapsed? The ring is gone now, leaving behind only data and a haunting question. Did we observe the death rattle of a star undergoing a transformation physics barely allows, or did we intercept a signature, a single page torn from a conversation happening on a scale we can hardly dream of. A ring of radio silence is one thing, but a star moving in deliberate defiance is another. Drifting in the sparse outer halo of Andromeda, far from the busy spiral arms, is a star astronomers have named Halo Anomaly 1. By all appearances, it is a star much like our own Sun, a stable, middle-aged yellow dwarf. Its composition is familiar, its temperature is normal, but its motion is not. This star is traveling backwards. In its region of the halo, every other star, every wisp of gas, every shred of cosmic debris is orbiting the galactic core in one dominant direction. A vast, slow river of motion dictated by the galaxy's formation billions of years ago. Halo Anomaly 1 is going the other way. It is a solitary salmon swimming upstream against the entire galactic current. This is astronomically bizarre. Imagine every car on an 8-lane highway flowing smoothly east, and then you spot one vehicle alone driving west at full speed in the fast lane. The forces required to put it there and to keep it there without being torn apart by gravitational interactions are immense. The standard astronomical explanation is galactic cannibalism. Andromeda, like all large galaxies, grows by consuming smaller dwarf galaxies. When a dwarf galaxy is torn apart, its stars are scattered into the halo, and sometimes they can be thrown onto chaotic, retrograde orbits. This is a well-understood process. The puzzle with Halo Anomaly 1 is its solitude. It is not part of a stream or a cluster of other captured stars, which is what you would typically find. It is utterly alone, a single backward-moving sun with no visible family or origin point. Its path seems too clean, too isolated to be the random debris of a cosmic collision. This profound isolation is what fuels a more speculative and captivating idea. What if this star is not a prisoner of the galaxy, but a visitor? For decades, science fiction has envisioned generation ships, colossal arcs that carry entire civilizations between stars over millennia. Now scale that idea up. A Kardashev-type 2 or 3 civilization, having mastered its home star, might look beyond its own galaxy. A journey across the intergalactic void would take eons, even at a significant fraction of light speed. Such a voyage would require a stable, long-lived power source. What better engine than a star itself? The concept of a Shkadov thruster is a theoretical megastructure, a colossal mirror or light sail positioned near a star to harness its own radiation pressure, slowly but surely pushing the entire star system in a chosen direction over millions of years. Halo Anomaly 1, with its sun-like properties and its impossibly retrograde orbit, fits a startling profile. It could be an arc that completed its immense journey from another galaxy, or perhaps from the deep, dark intergalactic wilderness. Its current backward orbit around Andromeda might not be a capture trajectory, but a parking maneuver, a deliberate entry into a stable, observational orbit around its new home. It is a breathtaking thought. We may be looking at a mobile home of cosmic proportions, its original civilization perhaps long evolved into something unrecognizable or still slumbering within, having traveled for 1 billion years to reach this new galactic shore. The star's light tells us it is normal, but its path through the dark tells a story of epic, intentional voyage. That solitary star on its backward journey speaks of immense, controlled power, a theme that echoes in a different, more violent corner of the galaxy. Near a dense star cluster in Andromeda, an object designated as Ulex M311 blazes with the fury of 1,000,000 suns, but only in the high-energy language of X-rays. It is an ultra-luminous X-ray source, a class of objects so bright they defy simple explanation. Typically, such brilliance comes from a stellar mass black hole or neutron star gorging on material ripped from a companion star, a process that creates a superheated accretion disk glowing with X-rays. But ULX M311 holds a secret in its furious output. It pulses. Deep within the torrent of high-energy radiation is a steady, repeating beat, a precise lighthouse flash cutting through the cosmic noise. The pulse period is exactly 0.0000693 seconds, a rhythm so unwavering it could set an atomic clock. This stability is the first clue that something unusual is at work. Neutron stars, known as pulsars, do emit regular pulses, but they are the rapidly spinning corpses of dead stars, and their pulses are tied to their rotation, which can and does change over time. The pulse from this object is too steady, too perfect, and it originates from an energy output far greater than a typical pulsar should be capable of sustaining without flying apart. When researchers analyzed this precise interval, a curious pattern emerged. Some scientists noted, half in jest and half in awe, that the pulse period bears a striking resemblance to a fundamental mathematical constant when expressed in certain units. It is not a perfect match, but it is eerily close to a value that appears throughout physics and geometry, a number that seems woven into the fabric of the universe itself. This numerical coincidence is the kind of detail that sends a chill down the spine of a theorist. Could it be a fingerprint? Natural cosmic processes are messy, governed by chaos and initial conditions that rarely produce such clean, symbolic numbers. The unyielding stability of the pulse suggests an engineered regularity, a metronome set by intelligence rather than gravity. This leads to two profound possibilities. The first is that we have discovered a new, natural type of cosmic engine, an extreme pulsar powered by physics we do not yet understand, perhaps involving exotic states of matter or magnetic fields of unimaginable strength. It would be a lighthouse of pure physics, its flash a testament to the universe's capacity for creating perfect rhythms in the midst of chaos. The second possibility redefines the scale of engineering. What if the X-rays are not the primary product, but merely a side effect? Imagine a civilization that needs to transmit power across interstellar or even intergalactic distances. The most efficient carrier for such a task might not be radio waves or lasers, but tightly focused beams of X-rays or gamma rays packed with immense energy. The pulse could be a modulation in that beam, a carrier wave for information, or a safety feature to prevent the beam from vaporizing anything that accidentally crosses its path. The object we see as an ultra-luminous X-ray source might, in this scenario, be the power plant's transmitter, a galactic-scale energy facility whose waste glow is bright enough to be seen from 2.5 million light-years away. Whether a newly discovered natural wonder or a piece of inconceivable infrastructure, this pulsing X-ray heart challenges our understanding of what is possible, reminding us that the line between a natural phenomenon and a technological artifact may be thinner than we think. A perfect cosmic metronome is a marvel, but our next mystery is defined by its profound silence and absence. Hidden within the Andromeda Galaxy, invisible to every telescope that sees light, is a gravitational knot. This is not a knot of stars or gas, but of dark matter itself. To understand this, we must first grasp what dark matter is. We cannot see it, touch it, or detect it directly with any instrument we have. We know it exists because of its gravity. Stars orbit the centers of their galaxies too fast to be held by the gravity of visible matter alone. Galaxies within clusters whip around each other at speeds that should tear them apart unless an immense, unseen mass is holding them together. This invisible scaffold, making up about 85% of the matter in the universe, is what we call dark matter. We map it indirectly through a trick of space-time called gravitational lensing. When light from a distant galaxy travels through the universe, it follows the curves in space-time created by mass. A massive object like a cluster of galaxies acts as a lens, bending and distorting the light from objects behind it. By studying these distorted, stretched, and sometimes multiplied images of background galaxies, astronomers can calculate the mass of the foreground object causing the lensing. And here is where Andromeda's knot appears. Detailed lensing studies have pinpointed a region in one of Andromeda's outer streams where the bending of light is incredibly intense and sharply defined. The math reveals a clump of dark matter so dense and compact it defies all standard cosmological simulations. Dark matter is thought to form a diffuse, wispy halo around galaxies, not tight, concentrated balls. This knot is an anomaly, a gravitational fist in the velvet glove of the galactic halo. The natural explanation points to a rare cosmic accident, the remnant core of a dwarf galaxy that was completely stripped of its stars during a merger long ago, leaving only its dense dark matter heart behind, orbiting Andromeda like a ghostly moon. Yet the extreme density challenges even this idea. This leads to a staggering possibility. What if this is not a natural remnant but a construction? A civilization that has progressed beyond harnessing stars might seek to manipulate the very fabric of the cosmos. Dark matter, with its weak interaction with light but strong gravitational influence, would be the ultimate building material for cloaking, for stability, or for engines of unimaginable scale. A dense knot of dark matter could serve as a gravitational anchor for a megastructure, a foundation hidden from prying eyes. It could be the core of a shield, deflecting radiation and debris on a galactic scale, or the heart of a propulsion system that warps space-time itself. We are left staring at a blank spot in the sky, a place where gravity tells us something immense resides while our eyes see nothing at all. Is this the fossil of a forgotten galactic collision, or is it the signature of a technology that has learned to sculpt the invisible bones of the universe? A gravitational knot of dark matter is a silent enigma, but some cosmic events announce themselves with brilliant, explosive light. In the Andromeda Galaxy, astronomers once witnessed a spectacle that seemed to defy random chance. Within a single Earth year, 3 separate stars erupted as classical nova. Now, a nova is a specific kind of stellar explosion. It happens in a binary star system where a dense white dwarf, the Earth-sized core of a dead star, orbits a normal star. The white dwarf's intense gravity steals hydrogen gas from its companion. This gas accumulates on the white dwarf's surface, heats up, and eventually ignites in a runaway thermonuclear explosion. The star can suddenly become hundreds of thousands of times brighter for a short period. Nova are not uncommon in a galaxy as large as Andromeda. Perhaps a few dozen occur each year. But the timing of these 3 particular events was extraordinary. They detonated in 3 widely separated spiral arms, hundreds of light years apart. Statistically, the odds of 3 such random, independent explosions aligning within such a narrow window are astronomically low, akin to rolling 3 dice and having each land on the same number 3 times in a row. The explosions were not simultaneous down to the second, but their light reached us within months of each other, a tight cosmic synchronization across an immense volume of space. This clustering in time, despite the vast distances separating the stars, presents a profound puzzle. Could it be a fluke, a 1 in a billion coincidence in a universe full of events? Certainly, that is the most conservative and likely scientific position. Yet, the nagging improbability invites us to consider a more radical line of thought. What if these nova were not random but triggered? The mechanism of a classical nova is well understood, a natural bomb with a predictable fuse based on the rate of stolen fuel. For a civilization with mastery over gravity and energy, manipulating such a system might be conceivable. Imagine being able to artificially increase the flow of hydrogen from the companion star to the white dwarf, or to inject a catalyst into the accumulating layer, pushing it over the critical threshold ahead of schedule. The purpose for such an act is where the speculation becomes truly fascinating. One possibility is communication. A synchronized triad of nova could be a beacon, a simple but unmistakable pattern stamped across the galaxy. It is a signal that does not require decoding a complex radio message. It simply states, "We are here and we can do this." Another idea is a test, a proof of concept for stellar engineering on a galactic scale. A culture might wish to map the precise effects of such explosions on the surrounding interstellar medium. using nova as tools to trigger or suppress star formation in specific regions. The most poetic theory, however, is that of cosmic art or celebration. For a galaxy-spanning civilization, what greater canvas exists than the spiral arms themselves? What more brilliant fireworks could there be than stars? The synchronized nova could be a monument, a fleeting sculpture of light and energy created for meaning we cannot grasp, perhaps marking an anniversary, a triumph, or a philosophical statement written in fire. Whether a rare statistical roll of the dice or the signature of a culture that treats stars as instruments, these three flashes of light, separated by centuries of travel time yet arriving on our doorstep together, ask us to consider if coincidence is the only explanation for harmony across such immense distances. The concept of synchronized stellar fireworks shifts our focus to a subtler, more permanent kind of cosmic architecture. Suspended in the void between a voracious black hole and a brilliant young star cluster, a ghostly thread glows with the universe's most violent light. This is the ghostly gamma-ray filament, a slender line of high-energy radiation stitching two celestial objects together across hundreds of light years. Gamma rays are the product of the most extreme events in the cosmos, the death cries of massive stars and the furious jets of supermassive black holes. To see them form a delicate, persistent filament is like finding a laser beam cutting through a fog bank, a line of perfect order within chaos. Such structures are exceptionally rare and remain one of the great puzzles of high-energy astrophysics. The natural explanation is a story of invisible forces and cosmic particle accelerators. Between the black hole and the star cluster lies a vast, diffuse magnetic field, a web of force lines woven through the interstellar medium. The black hole, even in a quiet state, can spew out fast-moving particles, while the massive, young stars in the cluster blast their surroundings with powerful stellar winds. These particles, electrons and protons moving at nearly the speed of light, become trapped by the magnetic field. Forced to spiral along the field lines, they emit gamma rays in a process called synchrotron radiation. The filament we see could be a magnetic highway, a specific, reinforced tube in this cosmic web where particles are funneled and concentrated, lighting up a path between an engine and a reservoir. It is a natural, if spectacular, power grid, with the black hole and stellar winds acting as the generators and the magnetic field as the transmission line. Yet the filament's precise geometry and longevity invite a more provocative interpretation. What if we are not looking at a natural magnetic flux tube, but at something that was built? Imagine a civilization that has mastered the harnessing of stellar and black hole energies. Transferring that power across interstellar distances would be a fundamental challenge. A focused beam of particles or energy, contained and guided, would be the solution. The gamma-ray filament could be the visible leakage, the slight bleed off from a contained conduit that is otherwise invisible, a cosmic power line humming with energy. In this scenario, the black hole is not a menace but a dynamo, and the young star cluster is not a nursery, but a city or a facility requiring immense power. The filament is the supply line. An even more staggering possibility reimagines the filament not as a conduit for energy, but as a path for travel. Theoretical warp drives and faster-than-light concepts often involve manipulating spacetime, creating corridors where the normal rules of distance break down. The energetic processes required to create or stabilize such a corridor would be unimaginably violent, potentially producing intense gamma radiation. Could this faint, enduring thread be the lingering signature of a stable warp lane, a tunnel through spacetime regularly used for transport between two important points? It would be a highway etched in radiation, its glow a permanent testament to journeys we cannot conceive. Whether a natural particle accelerator or a piece of inconceivable infrastructure, the ghostly gamma-ray filament forces us to see connections in the cosmos, to understand that objects separated by vast emptiness may be linked by threads of invisible force or perhaps by design. A cosmic highway of radiation suggests a universe connected by purpose, but sometimes the evidence of that purpose is chillingly direct. Orbiting a bloated, aging red giant star in one of Andromeda's distant reaches is a cloud of death. Astronomers first noticed it not by light but by shadow. The star's brightness would dip erratically, not with the clean, periodic curve of a planet's transit, but in a jagged, chaotic pattern of countless tiny eclipses. When they trained their spectrometers on the system, the data revealed the truth. This was not a diffuse ring of dust and ice like our own solar system's Kuiper belt. The spectral fingerprints were unmistakably metallic, showing strong signatures for iron, nickel, platinum, and other heavy elements. This is a dense, churning swarm of countless metallic objects, a blizzard of jagged shrapnel encircling the dying sun. A typical asteroid belt is a relic of failure, the leftover rubble from a solar system's birth that never managed to coalesce into a planet. It is a mix of rock, ice, and some metal, mostly pristine and untouched. This swarm is something else entirely. Its composition is unnaturally pure, as if someone had meticulously sorted the cosmic ore, discarding the stone and keeping only the valuable metals. The sheer density of the swarm is also bizarre. Natural gravitational interactions would have either coalesced the material or scattered it over billions of years. For it to remain in such a thick, chaotic cloud suggests a catastrophic and relatively recent disruption. The most compelling natural theory is one of planetary destruction. The red giant star, as it aged, expanded. Perhaps a close-orbiting, metal-rich planet, a world with an iron core the size of Mars, was caught in the star's swelling outer atmosphere. The friction and heat would have slowly ripped the world apart, vaporizing its mantle and crust, leaving only the shattered, molten pieces of its core to spiral in a doomed orbit. This is a tragic and plausible story, yet the spectral purity gives pause. Would a natural disintegration so perfectly separate the core metals from the rest of the planet's bulk? It seems improbably efficient. This is where the scene shifts from a natural tragedy to something more deliberate. Picture the final moments not of a natural death but of a harvest. Imagine a civilization confronting the inevitable expansion of their star. Rather than abandon their system, they undertake the ultimate engineering project, the systematic dismantling of their own world. They would strip away the crust and mantle, processing the silicate rock for construction or discarding it to reach the precious planetary core. They would fracture that core into manageable pieces, a glittering river of raw material to be used in constructing arcs or megastructures or to power their exodus. The chaotic swarm we see today would be the leftover debris field, the shattered remnants of the mining operation, still tumbling in the gravitational wake of the star that once warmed their home. The dying red giant, then, is not just a tomb but a silent witness to the most profound act of planetary recycling the universe could ever see. We are left to wonder if the shadow that passes before the star is merely a piece of debris or the ghost of a world that was sacrificed for the future of its children. The shattered remains of a world speak of an ending, but a lone wanderer in the dark hints at a journey still unfolding. Drifting in the immense, empty gulf between galaxies, a solitary world has been found. This is no ordinary planet, for it belongs to no star. It is a rogue planet, an orphan cast out from its birth system, condemned to wander the eternal cold of intergalactic space. Such worlds are predicted to exist dark and frozen, their surfaces only a few degrees above absolute zero. Yet when astronomers detected this one, designated rogue Andromeda 1, they found it was not dark at all. It glows not with reflected starlight, but with its own brilliant, shimmering light. Planet-wide aurorae dance across its entire surface, a constant, shimmering curtain of reds and greens and violets, turning this lonely wanderer into a ghostly lantern in the abyss. This is the central, beautiful impossibility. Aurorae, like our northern lights, are caused when charged particles from a star's solar wind slam into a planet's magnetic field, exciting gases in the upper atmosphere. But here, there is no solar wind. There is no star for trillions of miles in any direction. The particle stream that should be painting these lights simply does not exist. So what is powering this perpetual, global light show? The natural explanations are as fascinating as they are extreme. The planet could be immensely geologically active, with a molten core churned by intense tidal forces from a massive moon, or perhaps from the residual heat of a cataclysmic ejection from its home system. This geothermal heat could drive volcanic eruptions on a global scale, spewing charged particles into a strong magnetic field, creating an aurora from within. Another possibility involves a thick, hydrogen-rich atmosphere slowly collapsing under its own weight, generating internal heat and electrical currents that ignite the sky. Or the planet could be soaking up ambient particles from the incredibly thin intergalactic medium, focusing them with a powerful magnetic field into a faint but detectable glow. Each of these is a testament to a world of fierce internal violence, but the aurora's stability and global nature give pause. They are not sporadic flashes from random eruptions, but a constant enveloping shroud. This consistency leads to a hypothesis that redefines the word planet. What if the light we see is not a natural atmospheric effect, but the glow of civilization itself? Envision a world that was engineered for this very purpose, a mobile ark or a research station. Its entire crust could be threaded with a planetary-scale energy grid, powering continents of infrastructure beneath a protective shell. The aurorae would be the waste heat and light from that grid, bleeding through the atmosphere, the luminous signature of a world that is not dead but fully awake and functioning. The magnetic field required to contain such energy would be artificial, a generated shield against cosmic rays. More dramatically, consider the rogue planet not as a home but as a ship. An entire world fitted with a propulsion system of inconceivable scale. The constant aurorae could be the exhaust plume of that engine, the visible radiation from a reaction that is slowly, over millions of years, pushing the planet on a chosen course through the void. The energy source might be planetary, tapping the core's heat, or it might involve technologies that fuse elements in the mantle. This lonely, glowing dot in the darkness between galaxies becomes something entirely new, a vessel. Its journey is too slow for us to perceive, its destination unknown. It could be a generational ship from a distant galaxy, its original star long dead, now on a billion-year voyage to a new home. Or it could be a probe, a mobile observatory sent to study the local group of galaxies from the ultimate vantage point of the intergalactic deep. The light that reveals it is also the light that hides its true purpose. Is it a freak of planetary physics, a world so turbulent it lights its own way through the dark? Or is it a beacon, intentionally bright, announcing that even in the deepest voids, existence finds a way to not only survive but to shine? That lonely, glowing world suggests a voyage measured in eons, a timescale that brings us to an echo from an ancient past. Deep within the dusty lanes spiraling around Andromeda's core, astronomers have found a ghost. It is not the ghost of a star but of an event. Scattered across several large clouds of interstellar dust are faint, lingering glows known as light echoes. Think of a flash of lightning on a dark night. For an instant, everything is illuminated. Then the lightning is gone, but for a few moments afterward, you can still see the clouds it lit up glowing with that reflected light. These dust clouds in Andromeda are doing the same thing, but the flash they remember happened not seconds, but millions of years ago. When the light from that long-ago event finally reached Earth, some of it traveled directly to our telescopes. The rest took a detour, bouncing off these vast dust clouds before coming to us, arriving later and creating this delayed, ghostly repetition. By itself, a light echo is a beautiful natural phenomenon. The mystery lies in what the echo reveals. When scientists analyzed the spectrum of this ancient light, they found the unmistakable fingerprint of a quasar. A quasar is the most violently energetic object in the universe. It is the core of a galaxy where a supermassive black hole is feasting on an enormous amount of gas and stars. As this material spirals in, it heats up to millions of degrees, blazing with light that can outshine the entire galaxy that hosts it. The problem is Andromeda's core is quiet. The supermassive black hole at its heart, while enormous, is dormant, a sleeping giant with only a faint trickle of material falling in. There is no quasar in Andromeda today. Yet the echo proves beyond doubt that one blazed there millions of years in the past. So what woke the giant and what put it back to sleep? The natural explanation is a feast. Perhaps a large gas cloud or even a whole star cluster wandered too close to the black hole and was torn apart in a spectacular, millennia-long tidal disruption event. This would have provided the fuel for a temporary quasar, a brilliant flare that then faded as the last of the material was consumed. It is a perfectly reasonable cosmic story. But the sheer, focused power of a quasar sparks a more unsettling question. What if that feast was not a random accident of gravity, but a deliberate delivery? Consider the scale of energy a quasar releases. It is billions of times more powerful than all the stars in a galaxy combined. For a civilization that has mastered engineering on a planetary or stellar scale, the next logical leap is to harness energy on a galactic scale. The dormant black hole at the center of their galaxy is the ultimate battery waiting to be plugged in. The challenge is feeding it. Could an advanced culture have learned to guide massive amounts of material, entire gas clouds, or even engineered bundles of matter directly into the black hole's maw? They would, in effect, be throwing a switch, igniting the central engine of their galaxy for a specific purpose. The purpose is the greatest mystery of all. One possibility is pure energy harvesting. A temporary, controlled quasar could power a galaxy-wide civilization for millennia, its radiation captured by a network of collectors we can scarcely imagine. Another is communication. A quasar's beam is so intensely bright it could be seen across the universe. A deliberately triggered flare could be a message of unimaginable scale, a single, deafening shout to the cosmos saying, "We are here." Or it could be a tool. The energy from a quasar might be used for interstellar engineering, to clear vast regions of space or to catalyze star formation in distant arms. The echo we see today is the last fading reflection of that monumental act. The dust clouds are like ancient cave walls showing the silhouette of a brilliant, fleeting fire. We are left to wonder if that fire was a natural celestial wildfire or the controlled ignition of the greatest engine imaginable, a project so vast its only remaining trace is a whisper of light bouncing off forgotten dust. The ghostly echo of an ancient quasar fades, but at the very heart of Andromeda today, a more immediate and violent dance is underway. Astronomers have confirmed the galaxy's core is not home to one, but two supermassive black holes. They are locked in a gravitational waltz, orbiting each other in a decaying spiral that will culminate, millions of years from now, in a collision that will shake the fabric of spacetime itself. This binary system is a cosmic fossil, the undeniable proof of a past galactic merger, where a smaller galaxy was consumed and its central black hole captured. The dance is predictable in its grand strokes, but the details are not. As these monsters circle one another, they drag their respective accretion disks, the superheated rings of doomed matter spiraling into their event horizons. These disks should flicker and flare with chaotic violence, a random noise of infalling gas and friction. Yet observations reveal a subtle, periodic flickering superimposed on the chaos. It is a steady pulse, a rhythmic dimming and brightening that repeats on a timescale of weeks. This regularity does not match any standard model of merging black holes. The turbulence of two such immense gravitational fields churning together should erase any clean rhythm, not create one. So what is causing this cosmic heartbeat? The natural explanation points to complex, overlapping physics. As the black holes orbit, their gravitational tides may periodically squeeze or stretch their partner's accretion disk, causing regular surges in the flow of material and thus the light output. Or a dense, stable clump of matter might be orbiting within one of the disks, eclipsing the brilliant center like a moth fluttering around a flame, casting a predictable shadow with each pass. These are plausible, if difficult to model, natural phenomena, but the precision of the flicker invites a more staggering line of thought. Could the rhythm be a signature not of physics alone, but of structure? Imagine a civilization that has evolved not on a planet, but within the accretion disk of a supermassive black hole. It sounds like science fiction, but the concept has been seriously explored in theoretical papers. The environment is one of unimaginable extremes, with titanic energies and ferocious radiation. Yet, within the maelstrom, there could be islands of stability, orbits where the gravitational pull of the black hole and the centrifugal force of motion create a relative calm. For a culture mastering physics beyond our own, such a place could be the ultimate power source, tapping the black hole's rotational energy directly. The periodic flicker we detect could be the signature of their megastructures. Vast energy collectors known as Dyson satellites might orbit within the disk, their synchronized movements occasionally blocking our line of sight to the central fire, creating a deliberate pattern in the light. Alternatively, the rhythm could be a side effect of their technology, a pulse from immense engines that are actively stabilizing the disk or even gently nudging the black holes themselves, perhaps to control the timing of the eventual merger for their own purposes. To live between two dancing titans is to exist on the edge of oblivion, but also at the fountainhead of cosmic power. The flickering light from Andromeda's core may be the natural chaos of a doomed dance, or it could be the regulated pulse of a civilization that has made its home in the last place we would ever think to look, turning the end of worlds into an engine for eternity. The rhythmic flicker from a pair of dancing black holes speaks of controlled, immense power, but some cosmic objects are defined by a different kind of wealth. Far from the galactic core, a world of pure carbon drifts in the dark. Astronomers discovered it not by its own light, but by a trick of gravity called microlensing. When this planet passed in front of a distant background star, its gravity acted like a lens, magnifying and bending the star's light for a brief moment. That fleeting signal revealed a world with an atmosphere unlike any in our solar system, one choked with complex carbon compounds. This is a carbon planet. Imagine a landscape where the very air is thick with smog like hydrocarbons. The rain is not water, but a sticky drizzle of long-chain organic molecules. The seas are vast, sluggish pools of tar and crude oil, and the mountains sculpted by these strange fluids could be made of graphite or even solid diamond, forged by the immense pressures within the planet's crust. Such a world is a chemist's dream and an astronaut's nightmare. The formation of a carbon planet is a story of cosmic scarcity, but of the wrong ingredient. Our solar system formed from a cloud rich in oxygen, leading to rocky worlds built from silicates, which are compounds of silicon and oxygen. But if a star system forms from a cloud that is carbon-rich and oxygen-poor, the chemistry shifts dramatically. In that environment, carbon atoms seize the available oxygen to form carbon monoxide, leaving little oxygen left to make rocks. Instead, carbon itself becomes the building block. Planets condense from carbides, compounds of carbon and metal, and their atmospheres become saturated with sooty, complex hydrocarbons. It is a natural, if exotic, outcome of stellar chemistry. Yet the sheer, overwhelming abundance of carbon on this detected world gives one pause. Could such a perfect storm of elements occur naturally? This question opens the door to a much darker and more intriguing possibility. What if this is not a natural world but an artificial one? Consider the scale of a galaxy-spanning civilization. Its industry, spanning millions of stars, would produce waste on an unimaginable scale. The most stable, long-term way to dispose of certain types of industrial byproducts, particularly carbon-based waste, might be to sequester it. They could gather the soot of 1 million fusion reactors, the spent carbon scaffolds of nanoassemblers, and the hydrocarbon residues of 1 billion chemical processes, and compact it all into a single, designated repository, a garbage world. This planet would be a cosmic landfill, a permanent tomb for the discarded materials of an entire galactic culture. Its tar seas would be dumping grounds, its diamond mountains compressed strata of refined waste. But there is an even more purposeful alternative. What if the planet is not a dump but a factory? Carbon is the foundation of life as we know it, and in advanced nanotechnology, it is the key to building materials with incredible strength and flexibility, like graphene and carbon nanotubes. A civilization that has mastered molecular engineering might need a dedicated production facility. A carbon planet would be the ultimate resource mine and manufacturing site combined. Its atmosphere provides the raw feedstock. Its intense internal pressures could forge diamondoid structures naturally, and its entire lithosphere could be one vast, self-replicating nanofactory, producing materials for megastructures across the galaxy. The planet would not be a wasteland, but a humming, automated industrial hub, its surface constantly reshaped by purposeful activity. So is this carbon-drenched world a rare natural jewel, a glittering testament to the universe's diverse chemistry? Or is it the ultimate recycling center, or perhaps a forge where the bones of future galaxies are quietly being shaped? Its silent orbit offers no easy answer, only the profound suggestion that what we classify as a natural wonder might, upon closer inspection, reveal the fingerprints of a universe not just lived in but actively worked upon. A line of stars can be a constellation, a trick of perspective, but what if the line is real? Within one of Andromeda's spiral arms, a stellar string defies the natural chaos of the galaxy. A dozen brilliant, massive stars, all of similar age and composition, are arranged in a near-perfect straight line that stretches for over 1,000 light-years. This is not an illusion. These stars are physically connected, a cosmic ruler etched in blue-white fire across an immense void. Star formation is a messy, turbulent business. It happens within swirling, collapsing clouds of gas, resulting in clusters and associations that are lumpy and irregular. Nature does not build in straight lines on this scale. The existence of this string is a geometric anomaly written across the heavens. So how did it form? The leading natural explanation is a story of cosmic dominoes. A supernova shockwave, or perhaps the gravitational ripple from a merging black hole, could have raced through a particularly long, thin filament of cold molecular gas. This immense pressure wave would have compressed the gas at multiple points along its length simultaneously, triggering the collapse of a dozen stellar nurseries at once, like a fuse lighting a series of bombs. The stars that ignited would be siblings, born from the same event and the same ribbon of material, hence their similar age and makeup. Their straight-line formation would simply mirror the shape of the original gas filament. It is an elegant, violent, and plausible story, yet the precision of the arrangement gives one pause. Shockwaves tend to expand and distort. They do not usually create such clean, enduring geometric patterns across 1,000 light-years of turbulent space. This precision is the crack through which a more extraordinary idea shines. Could this be a landmark for a spacefaring culture that navigates by the stars? What greater signpost could there be than a line of suns? Imagine a civilization embarking on interstellar travel before the invention of advanced electronics or faster-than-light communication. Their voyages would take generations, and they would rely on the fixed patterns of the cosmos to chart their course. A perfectly straight line of brilliant, massive stars would be unmissable. It would function as a galactic highway marker, a beacon saying, "Follow this line to reach a specific destination, a hub world, a resource-rich nebula, or the civilization's home." The concept of a starway takes this further. It suggests these stars were not just found but made. Could a sufficiently advanced culture ignite stars? Theoretically, if you can gather and compress enough hydrogen gas, you can. Perhaps they did not create the stars from nothing, but instead moved pre-existing stellar nurseries into alignment over eons, using gravity or other means to sculpt this permanent guidepost into the fabric of their galaxy. Each brilliant point in the line would be a rest stop, a waypoint with resources, or simply a mile marker confirming you are on the correct ancient path. The stellar string hangs in the darkness, a question written in nuclear fire. Is it the fossilized echo of a single catastrophic shockwave that briefly brought order to the chaos of creation? Or is it the oldest road sign in the universe, a monument to a time when travelers looked to the stars not just for wonder, but for direction, a path home carved from suns themselves? A straight line of stars is a beacon you cannot miss, but the greatest structures might be the ones you cannot see at all. This brings us to the most famous hunt in all of speculative astronomy, the search for a Dyson sphere. The theory is both simple and staggering. A civilization that has exhausted the energy of its planet would look to its sun. To capture nearly all of that star's output, they would build a shell of collectors around it, a megastructure that would render the star dim or even invisible light, while glowing fiercely in the infrared from the waste heat. In Andromeda, one star stands out as a prime candidate in this cosmic search. Designated M31V1, this otherwise ordinary star behaves in an extraordinarily strange way. Its light does not dip with the clean, predictable rhythm of an orbiting planet. Instead, it fades erratically in deep, jagged troughs that never repeat. One month it might dim by 15% for a few days, then years later it might drop by 40% for a week, in a pattern that looks less like an orbit and more like a swarm of flies passing in front of a lamp. The first task of science is to rule out natural causes, and astronomers have pursued every possibility with relentless rigor. Could it be a vast, ragged disk of dust and debris, the kind that surrounds young stars? The star's spectrum shows it is mature, not young, and such disks tend to create symmetrical, repeating dimming patterns, not this chaos. Could it be a gigantic cloud of comets, millions of them, on long, plunging orbits? While a comet swarm could create irregular dips, the sheer scale and frequency of the events on M31V1 would require an implausibly vast and dynamic reservoir of icy bodies, one that should show other signs like gas emissions which are not seen. Each natural explanation hits a wall when confronted with the data. This leaves a haunting possibility on the table. What we might be witnessing is the signature of construction, a Dyson swarm in its intermediate stages. Imagine not a solid shell, but a vast, evolving constellation of individual energy-collecting satellites, numbering in the billions or trillions, each on its own independent orbit around the star. Their combined movements would create an ever-shifting, patchy veil, blocking the star's light in a complex, non-repeating pattern exactly like the one observed. The dips would be deep when a dense cluster of collectors transits and shallow when the swarm is sparse. It would be a living, growing infrastructure, its shadow a testament to an ongoing project of stellar-scale engineering. Today, telescopes across the world and in space keep a permanent watch on M31V1. Every new dip is analyzed, its shape and duration fed into supercomputers to model millions of possible configurations, from natural debris clouds to artificial swarm geometries. The star has become a laboratory for a new kind of astronomy, one that asks not just what is, but what could be built. It is a silent test case at the frontier of our imagination, a flickering candle in the Andromeda Galaxy that may or may not be surrounded by a civilization learning to hold its sun in its hands. The search for a Dyson swarm scans for the shadows of industry, but the most direct call we might ever receive would come not in darkness but on a specific, silent frequency. In the year 1977, a radio telescope in Ohio caught a 72-second burst of sound so powerful and so unusual that the astronomer who printed the data circled it and wrote one word in the margin: "Wow." That signal, never heard again, became a legend. Decades later, a similar chill ran through the astronomy community. In the early 2000s, a radio observatory trained on the Andromeda Galaxy recorded a nearly identical event. For a brief window, a powerful, narrowband radio signal erupted from a seemingly empty point between the stars. It was a cosmic shout on a very specific channel, a frequency near 1420 MHz, which is the natural emission line of neutral hydrogen, the most common element in the universe. Broadcasting on that frequency is like building a lighthouse at the busiest port in the world, a logical place for any civilization to look or to send a signal meant to be found. The detection was clear, strong, and utterly singular. It was never heard again despite years of frantic, dedicated follow-up observations pointing every available dish at that lonely coordinate. The mystery of this Andromeda WOW signal is defined by its perfect, frustrating ambiguity. On one hand, the universe is full of transient radio bursts. Pulsars can have off moments, stellar flares can emit radio noise, and collisions between exotic objects can create brilliant, one-time flashes. A natural explanation is not just possible, it is statistically likely. Yet the signal's characteristics nag at the imagination. It was narrowband, meaning it was focused on one very specific frequency, unlike the broad, messy static of most natural cosmic events. It was also incredibly strong, implying an immense release of energy focused into a very tight beam, a beam that, by chance, was pointed directly at Earth for a fleeting moment. This combination is what fuels the other, more profound possibility. What if it was not a natural burst but a deliberate transmission? Consider the scale. To send a signal that strong across 2.5 million light-years would require a transmitter of almost inconceivable power, harnessing the energy of stars. Such an effort would not be casual. It would be a deliberate attempt to make contact. The fact we caught it only once could mean we just happened to be listening during the brief instant their beacon swept across our solar system, like catching the flash of a distant lighthouse as its beam rotates through the darkness. We may have intercepted a hello meant for the entire galaxy, a ping into the void that our antennas were perfectly positioned to catch for just a few seconds. The silence that followed is just as telling. If it was a natural event, its one-off nature is simply part of the chaotic cosmos. But if it was a message, the silence could be a protocol. They spoke once clearly on the universal hydrogen line, and now they wait, listening for a reply from anyone clever enough to have been listening and bold enough to answer. That empty point in Andromeda now holds a different kind of weight. It is not the location of a strange star or a dark knot of matter, but the origin point of a question. Was it a cosmic accident, a random crackle of stellar lightning? Or was it a moment of historic significance, a call placed across an ocean of time and space that reached our shores and to which we have yet to respond? A star on the run carries a different kind of story. Streaking out from Andromeda's spiral disk is a brilliant blue-white beacon, a massive O-type star moving at over 500 kilometers per second. This velocity is not just fast, it is a cosmic jailbreak. The star is moving faster than the galaxy's own escape velocity, meaning the collective gravity of hundreds of billions of suns cannot pull it back. It is a runaway destined to flee into the intergalactic void forever, leaving its home galaxy behind as a fading memory. We call these objects hypervelocity stars, and their origin is typically written in violence. The standard explanation involves a gravitational catapult. One scenario begins with a binary star system, two stars locked in a close orbit. If one of them goes supernova, the explosion can be lopsided, kicking the remaining star like a rifle shot, sending it careening across the galaxy at tremendous speed. The other, more dramatic scenario takes place at the galactic core, a binary star system wandering too close to the supermassive black hole can be torn apart. The black hole captures one star, binding it in a tight orbit, and in a gravitational slingshot of unbelievable force, flings its companion outward at a significant fraction of light speed. It is a cosmic cannon with a black hole for a barrel. Yet, for this particular runaway, the forensics are inconclusive. Astronomers have traced its path backward, looking for the scene of the crime, the remnant of a recent supernova, or the specific region around the central black hole where such an interaction would have occurred. The trajectory does not point neatly to any known explosive event or to the core with the precision the models predict. It is as if this star simply decided to leave, acquiring its incredible speed from a source we cannot yet see. This missing point of origin is the crack in the story where speculation floods in. Could this be a slingshot maneuver of a different kind? Imagine a vessel, a starship of unimaginable scale, needing to accelerate to relativistic speeds for an intergalactic journey. The most efficient engine in the galaxy is gravity itself. A close, calculated pass around the supermassive black hole at Andromeda's heart would provide the ultimate gravitational boost, a maneuver that could impart exactly this kind of velocity. The star we see might not be a natural star at all, but the propulsion module or the external shield of such a vessel, glowing with the friction of its own passage, its course set for a destination beyond the galactic horizon. There is a darker, more staggering possibility. What if the star is not a vessel but a projectile? Consider a conflict not between nations, but between civilizations that command the forces of stars. In a war fought on a galactic scale, what would be the ultimate weapon? You might not build a bomb, you would simply aim a star. A technology capable of manipulating gravity or space-time could, in theory, wrench a star from its orbit and hurl it at an enemy system or world. The kinetic energy alone would be apocalyptic, sterilizing entire sectors of space. This hypervelocity runaway, then, would not be an escapee but a missile that missed. Its trajectory is not an arc away from an explosion, but the final, fading line of its fired path, a silent reminder that some conflicts are so vast their ammunition is sung from the furnaces of creation itself. Whether a natural survivor of stellar chaos, the wake of a purposeful voyage, or a weapon from a war we cannot comprehend, this star's flight is a permanent signature of immense force, a sentence written in light across the dark, declaring that sometimes to understand a galaxy, you must look at what is desperately trying to leave it. A star fleeing its galaxy speaks of forces that bend the laws of motion, but a quiet, cooling ember in the halo challenges the laws of time itself. Drifting in the sparse outskirts of Andromeda is a white dwarf star of profound antiquity. A white dwarf is the final, glowing cinder of a star like our Sun, a dense Earth-sized sphere of carbon and oxygen that slowly radiates its residual heat away into the void over billions of years. By measuring its temperature and brightness, astronomers can calculate how long it has been cooling, essentially reading its age from its fading warmth. The measurement for this particular white dwarf, catalogued as Halo WD1, returned a number that caused a profound silence in observatories around the world. Its cooling age appears to be older than the estimated age of the universe. This is not a small discrepancy. It is a direct, unsettling paradox. A stellar corpse cannot be older than the cosmos that birthed it. The immediate and responsible scientific response is to question the measurement itself. Could there be a systematic error? Perhaps our models of white dwarf cooling are incomplete. Maybe the star has an unusual composition that changes how quickly it radiates heat, or it could be surrounded by a faint, unseen disk of dust that is dimming its light, making it appear cooler and thus older than it truly is. Astronomers have scrutinized every variable, refining their models of stellar physics to account for different mixtures of elements in its core, different rates of crystallization, and the effects of residual magnetic fields. Yet, even with the most generous error bars, the age of this white dwarf stubbornly pushes against the very beginning of time. It stands as a persistent outlier, a data point that refuses to fit neatly into our cosmic timeline. This forces us to consider possibilities that stretch the fabric of reality. One mind-bending idea is that this white dwarf is a relic from a previous cosmic cycle. Some cosmological theories suggest our universe is not the first and may not be the last, that it undergoes cycles of expansion, contraction, and rebirth in a big bang, a big crunch, and then another bang. In this model, it is conceivable that a few incredibly dense, stable objects like white dwarfs or neutron stars could survive the collapse of one universe and be carried over into the next. Halo WD1 would then be a cosmic fossil, a piece of debris from a universe that existed before our own, its light a message from a time that, by our current definitions, does not exist. It would be a wanderer from eternity. An even more staggering possibility involves not cycles of universes, but a manipulation of time itself. Einstein's theory of relativity tells us that time is not absolute. It flows at different rates depending on gravity and velocity. An object moving at an extreme fraction of light speed, or one that has orbited an incredibly powerful gravitational source, experiences time more slowly relative to the rest of the universe. This is time dilation. We know it happens on small scales. The clocks on GPS satellites must be adjusted for it. Now, imagine that effect pushed to an unimaginable extreme. What if this white dwarf, or the star that formed it, was once part of a grand experiment or a catastrophic accident? Could it have been propelled to relativistic velocities by a natural event we cannot conceive, or perhaps by an engine, and spent eons traveling at near light speed before returning to normal space? From its perspective, only a few billion years passed. From the perspective of the wider universe and from ours, many more billions of years elapsed. Its internal clock would be out of sync with cosmic history, making it appear older than its surroundings. Alternatively, what if it spent a long period deep within the gravity well of something even more extreme than a black hole, a region where spacetime itself was so warped that time nearly stood still for it? The white dwarf would be a traveler not just through space but through time, a clock that ticked at a different rhythm than the rest of creation. Whether a survivor from a prior reality or a testament to manipulated time, this ancient cinder forces a humbling realization. Our understanding of cosmic history is written in the light we see, but that light may tell stories of journeys and origins that rewrite history itself. This quiet, cold point of light in Andromeda's halo is not just an old star, it is a question mark placed at the very beginning of time. That ancient white dwarf challenges the timeline of the cosmos, but a gas giant in Andromeda's embrace challenges our very definition of life. The detection was subtle, a faint but distinct fingerprint in the planet's atmosphere. When astronomers analyzed the spectrum of light filtering through the alien air of this distant world, they found a tentative signal for phosphine. On Earth, phosphine is a simple molecule, one phosphorus atom bonded to 3 hydrogen atoms. It is also notoriously difficult to make through ordinary geology or chemistry on a rocky world. Here, it is almost exclusively associated with life. Anaerobic bacteria deep in swamps and in the guts of animals produce it industrially. When phosphine was controversially detected in the clouds of Venus, it ignited a firestorm of debate about potential microbial life in our own solar system. Now, that same debate has leaped 2.5 million light-years to a gas giant orbiting a star in Andromeda. The planet itself is a behemoth, many times the mass of Jupiter, a world of crushing pressures and swirling, colorful bands of gas. It orbits far from its star, a cold, dark giant. In such an environment, phosphine should not last. it should be rapidly broken apart by ultraviolet radiation or consumed in other chemical reactions. Its presence, if real, implies something is constantly replenishing it. The scientific community is divided and the discussions are intense. One camp argues for exotic, unknown geochemistry. Deep within the planet's immense atmosphere, at pressures and temperatures we can barely simulate, perhaps strange mineral surfaces catalyze the formation of phosphine from simpler compounds. Lightning storms of unimaginable scale might provide the energy to forge the molecule in the upper clouds, or the phosphine could be dredged up from the planet's deep, hot interior, where thermodynamics favor its creation and powerful convection currents carry it to where we can see it. These are all natural, if poorly understood, possibilities, but the phosphine signature, faint as it is, points toward the profound. If every known non-biological process fails to explain its abundance, we are left with a staggering hypothesis. Could the clouds of this distant gas giant be alive? It is a radical idea, but not an impossible one. On Earth, we find extremophiles thriving in boiling acid, in crushing ocean depths, and in radioactive waste. The temperate layers of a gas giant's atmosphere, where pressure and temperature are just right, could theoretically host a floating biosphere. Microbial life could exist there, drifting on the winds, harvesting chemical energy from the atmosphere below. Their metabolic waste product could be the phosphine we see. This would not be the complex technological life we imagine when we think of aliens. It would be simple, microbial, a vast, floating microbial mat spanning an entire planet. But it would be life, and it would be the first sign that biology exists beyond the Milky Way. The implications would shake science to its core. It would mean life is not a rare, miraculous accident confined to our galactic neighborhood, but a common, almost inevitable process that arises wherever conditions permit, a cosmic imperative. The detection is still tentative, and everyone involved cautions that extraordinary claims require extraordinary evidence. The race is now on for confirmation. The next generation of space telescopes, like the planned Habitable Worlds Observatory and colossal ground-based instruments with mirrors over 30 meters across, are being designed with this exact goal in mind. They will stare at this distant gas giant for hundreds of hours, gathering every photon of light to build a definitive spectrum. They will look not just for phosphine, but for other corroborating biosignatures, like the simultaneous presence of oxygen and methane, or unusual ratios of gases that hint at metabolic activity. We are on the precipice of an answer. Is that faint spectral line a trick of the light, a quirk of alien chemistry we do not yet understand? Or is it the first faint breath of another living world, a message written in the atmosphere of a giant, telling us we are not alone in the vast, dark ocean between the stars? The faint whisper of phosphine is a chemical mystery, but the fabric of space itself can carry a far more violent story. In the silent listening posts of Earth, a network of lasers and mirrors known as LIGO and Virgo once caught a fleeting tremor in reality. It was the distinctive chirp of gravitational waves, ripples in space-time caused by the most cataclysmic events in the universe. The signal matched the final, spiraling dance and collision of two black holes, each roughly 50 times the mass of our Sun. This was not unusual in itself. What happened next was, when scientists triangulated the origin of these waves, the coordinates pointed with startling precision to a quiet, unremarkable patch of the Andromeda Galaxy. This was the expected source. The shock came when every optical, X-ray, and radio telescope on Earth and in orbit swiveled to look. They saw nothing. No flash of light, no afterglow, no swirling disk of debris. The merger was completely dark. This absence is a profound violation of expectation. When black holes of this size merge, they are typically surrounded by an accretion disk, a superheated whirlpool of gas and dust torn from their surroundings. The violent collision should fling this material outward in a brilliant burst of light across the spectrum, a kilonova or a gamma ray burst that shines for days. The silence from Andromeda was deafening. It meant these black holes merged in perfect isolation, in a void so clean it defied the dusty, gas-rich environment of a spiral galaxy. They found nothing but empty space, so what created the perfect vacuum for a dark merger? One natural possibility is a globular cluster, a dense ball of ancient stars where black holes can sink to the center and pair off, their surroundings long ago stripped clean by stellar winds. Yet no known globular cluster exists at that exact point. Another idea suggests a primordial black hole merger, objects formed in the chaos of the Big Bang itself, wandering the galaxy in pristine darkness. Both are valid if exotic, astrophysical explanations, but the utter cleanliness of the event, the total lack of any electromagnetic whisper, opens a door to a more staggering line of thought. Could the chirp have been artificial, not a natural collision but a controlled one? Imagine a technology that manipulates gravity not for propulsion but for construction or communication. The merger of two massive, cloaked artificial objects, perhaps components of a megastructure being assembled or reconfigured, would release a burst of gravitational waves identical to a black hole collision. Their engineered nature could explain the absence of light. They would be built from materials that leave no glowing debris, designed to interact only through gravity. An even more profound theory reimagines the signal not as a merger but as a switch. A civilization that has learned to warp space-time on a stellar scale might use controlled gravitational wave emissions as a tool. The precise chirp could be the signature of activating or deactivating a massive gravity-manipulating device, a generator for a warp field, a stabilizer for a wormhole throat, or the ignition of a drive system for a structure larger than a star. The burst of waves would be the startup noise of an engine of cosmic proportions, a single, resonant note played on the strings of space-time itself. The telescope saw nothing because the machinery operates in a realm beyond light, its workings hidden in the geometry of the universe. That faint chirp, lasting less than a second, thus becomes a cipher. It is either the signature of the cleanest, most isolated natural event ever witnessed, or it is the first detectable sound of a technology that builds with gravity and moves through dimensions we are only beginning to fathom. The silence that followed the tremor may be the most telling part of the story. That gravitational chirp from a silent merger speaks of hidden forces, but a different kind of hidden order glows in a shell of stellar death. Among the many planetary nebulae in Andromeda, the beautiful final breaths of dying suns, one stands apart. Catalogued as the Crystal Nebula, it should be a chaotic cloud. When a star like our Sun reaches its end, it gently puffs off its outer layers, creating an expanding sphere of incandescent gas, a cosmic bubble of oxygen, carbon, and nitrogen illuminated by the hot core left behind. This gas should be amorphous, a luminous fog, but the light from this nebula tells a different story. Its spectrum contains sharp, narrow emission lines and unusual polarization signatures that are the telltale fingerprints of crystalline structures. In certain regions, the data suggests the nebula material is not a random gas, but is arranged in ordered lattices, as if the cloud is studded with cosmic geodes the size of solar systems. This presents a beautiful and profound puzzle. How can a crystal form in the near-perfect vacuum of space and on such an immense scale? Crystals need time, pressure, and a stable environment to grow their orderly atomic structures. The turbulent, rapidly expanding shell of a planetary nebula is the exact opposite of that. It is a place of violent change and extreme thinness. For crystals of this apparent size to exist, something extraordinary must have happened. The leading natural theory is one of rapid freezing. As the star's ejected material raced outward, it may have encountered a region of space that was unexpectedly cold, perhaps due to a shadow from a dense dust cloud. The sudden, extreme temperature drop could have caused certain molecules, like silicates or carbon compounds, to snap into crystalline form almost instantly, like a breath freezing in midair. It would be a fleeting moment of order captured in the act of expansion, yet the scale and specific signatures push against this simple chill. The crystals seem too large, too well formed. This leads to a more staggering possibility. What if the dying star's ejector did not freeze on its own but was imprinted? Imagine the expanding shell of gas over centuries encountering a pre-existing invisible scaffold, an immense lattice of crystalline material hanging in the void. This would not be a natural asteroid or a comet, but a fragment of something truly colossal, a structure built from a transparent, ordered material strong enough to survive in interstellar space. As the nebular gas washed over this cosmic trellis, the material could have coated it, adhering to the latticework and taking its shape like ivy growing on a wrought iron fence. The glowing nebula we see today would then be a perfect cast, a luminous mold of this hidden architecture. What could such a lattice be? One poetic idea is that it is a remnant of a world that was not rocky or gaseous but crystalline. A planet or megastructure forged from a single growing mineral matrix, perhaps shattered long ago by a cataclysm, leaving this one jagged fragment adrift. Another, more functional theory suggests a purpose. A crystalline lattice of that scale could have been a collector, a cosmic antenna designed to focus specific types of energy or radiation from the galaxy. Or it could have been part of a stabilization frame for something even larger, a piece of engineering so vast its broken shards are light years across. The crystal nebula, then, is not just the tomb of a star. It is a luminous blueprint, a flash of light revealing the ghostly outline of a skeleton we were never meant to see, a fossil of intelligent geometry waiting in the dark for a star's death to give it form. The silent geometry of a crystal nebula gives way to a rhythm, a pulse that echoes across the void with the precision of a metronome. In the crowded stellar fields of Andromeda, a millisecond pulsar spins with impossible speed, completing over 600 rotations every single second. This dense, city-sized remnant of a supernova is a natural lighthouse, its beams of radio waves sweeping past Earth with a regularity that rivals our most advanced atomic clocks. Yet when researchers, as they sometimes do, converted the tempo of its pulses into audible sound waves, they heard something that made them pause. The pulses did not just create a steady click. They resolved into a distinct, repeating five-note sequence, a simple, haunting tune that cycled over and over against the backdrop of cosmic static. This discovery immediately confronts us with a fundamental aspect of human psychology, a phenomenon known as apophenia. It is our brain's relentless drive to find meaningful patterns in random data, to see faces in clouds or hear hidden messages in recorded static. The universe is a noisy, chaotic place, and statistical probability dictates that given enough random pulses, some will, by sheer chance, arrange themselves into a sequence that our pattern-seeking minds interpret as order, even music. It is overwhelmingly likely that this pulsar's five-note song is a beautiful accident, a cosmic Rorschach test where we are the ones composing the melody from nature's random notes. But the remotest possibility invites a far more profound question, one that lingers at the edge of science. What if the pattern is not in our perception but in the star? Could this be a natural cosmic music box? The physics of a pulsar are extreme, governed by its rotation, its magnetic field, and the flow of charged particles around it. It is conceivable that some complex, resonant interaction within this ferocious environment could create a slight, periodic variation in the pulse intensity, a natural vibrato that our instruments pick up as a rhythmic sequence. It would be a rare and stunning example of the universe creating its own simple harmony from pure physics. The other side of that question, however, redefines the scale of what might be possible. What if the pulsar's spin was not left to chance? The idea of modulating a pulsar, of artificially altering its spin or emission to encode a signal, is an engineering concept of almost unimaginable scale. It would require a technology capable of interacting with a star's core, of applying precise forces to an object with the mass of a sun compressed into a sphere the size of a city, all while it spins hundreds of times per second. Yet, if it could be done, a pulsar would be the ultimate galactic lighthouse. Its signal is powerful, penetrates dust clouds, and is unmistakably artificial in its regularity. Modulating that signal into a simple, repeating melody would be a beacon that shouts intelligence. It would not be a complex message of mathematics or language, but something more fundamental, a signature. It says, this rhythm is not natural chaos, it was made. Anyone, anywhere in the galaxy who learns to listen to the radio sky would eventually find this one peculiar star that sings a 5-note song, a permanent monument in the symphony of the cosmos that states simply, listen. We were here, so we are left with a solitary, spinning heart in Andromeda, broadcasting its quick time beat. Is its tiny song a testament to the human need to hear music in the machine of the universe? Or is it the faint, enduring echo of a hand that once reached out to tune a star, leaving a calling card for the ages, written not in words or pictures, but in a few pure, repeated notes? The pulsar itself offers no answer, only its endless, rhythmic question played on a loop across the light years. The pulsar's rhythmic song is a beacon in the void, but some gatherings in the cosmos choose utter silence. Deep within a sparse region of Andromeda's halo, astronomers have mapped a cluster of ghosts. They call it the dark star cluster. This grouping of objects reveals itself not by any glimmer of light, but solely by the gentle, persistent tug of its gravity. As background stars drift slowly across this patch of sky, their paths bend ever so slightly, as if flowing around an invisible boulder in a stream. The combined gravitational pull paints a clear picture, a compact swarm of massive bodies, each many times heavier than Jupiter, orbiting one another in a loose dance. Yet when telescopes scan the same area in every wavelength, from radio waves to gamma rays, they see absolutely nothing. No infrared warmth, no X-ray flicker, no visible spark. It is a gathering of shadows with profound mass. The first task of science is to propose natural explanations, and there are several compelling candidates. The most likely is a swarm of failed stars known as brown dwarfs. These are objects too massive to be planets, but not massive enough to ignite sustained nuclear fusion in their cores. They form like stars but fade into cool, dark embers. A cluster of ancient, cold brown dwarfs could indeed be massive enough to bend starlight while emitting virtually no detectable radiation of their own. Another possibility is a collection of primordial black holes. These are not the corpses of dead stars, but hypothetical black holes forged in the dense, searing conditions of the Big Bang itself. They could range in mass from a small asteroid to many times that of a star, and a cluster of them would be perfectly dark, revealing themselves only through gravity. A third idea involves orphaned neutron stars. When a massive star explodes, its core can collapse into a city-sized ball of pure neutron matter, spinning furiously and often emitting beams of radiation as a pulsar. But if that neutron star is kicked away from its birthplace at high speed, and if it has no companion star to feed from and no strong magnetic field to generate beams, it could cool and darken into a silent, ultra-dense cinder, invisible against the black. Each of these natural explanations is plausible, yet each faces challenges. A cluster of brown dwarfs this dense should have left some infrared trace, a faint collective warmth that our most sensitive instruments like the James Webb Space Telescope should have glimpsed. Primordial black holes remain entirely theoretical. We have never confirmed their existence, and a cluster composed solely of kicked, dormant neutron stars would be a statistical marvel, as such objects are rare and their formation should scatter them, not bind them together in a group. The very cleanliness of the data, the total absence of any electromagnetic whisper, is what keeps the door open to a wilder possibility. What if the darkness is not a natural state but a chosen condition? Imagine a fleet, not of ships as we conceive them, but of world-sized habitats or generation arcs designed for journeys that span millennia. Such vessels, to survive the hazards of interstellar space, cosmic rays, micrometeoroid impacts, and the prying eyes of others, might be built with cloaking technology. Their hulls could be perfect absorbers, engineered to swallow every photon that strikes them, emitting no thermal signature, reflecting no starlight. They would be blacker than the void itself. If a convoy of these arcs were to gather, perhaps to exchange resources, transfer populations, or simply wait in a designated holding area before embarking on the next leg of a galactic migration, they would appear to us exactly as this cluster does, a gravitational knot of massive, compact objects radiating absolutely nothing. Their silent congregation would be a strategic pause in an epic, slow-motion voyage. The dark star cluster hangs in the halo, a profound question mark. It is either a natural cemetery for the galaxy's dark and failed children, a place where objects that never truly shone have gathered in the cold, or it is a parking lot. A temporary harbor for titanic vessels that have mastered light and heat, resting in the darkness between one unimaginable journey and the next. Our instruments tell us something is there, something with weight and presence. But the silence that surrounds it is the loudest part of the mystery, a silence that could be the emptiness of dead matter, or the careful, deliberate quiet of something that is very much awake. A cosmic explosion should be a single, definitive event, a star's final, brilliant scream. But in Andromeda, one star died with a stutter. Astronomers watched as it erupted in a brilliant supernova, a flash that should have peaked and then faded steadily into the long night. Instead, after its initial bright peak, the light began to dim as expected. Then, months later, as telescopes were turning away, the dying ember flared back to life. A second, distinct peak of light emerged from the fading glow, as if the star had found one last, desperate breath. This bizarre, double-peaked light curve is a signature of profound complexity. In the natural world, such a staggered death points to a star with a troubled history. One compelling explanation involves a dense shroud of circumstellar material. Imagine a massive star in its final millennia, shedding its outer layers in violent, episodic eruptions long before the final cataclysm. This expelled gas forms a thick shell of material, a cosmic cocoon drifting a short distance from the star. When the core finally collapses and the supernova shockwave erupts outward, it first slams into this pre-existing shell. The collision generates the initial, tremendous flash of light. The shockwave plows through the shell and emerges into the thinner interstellar medium, and the light begins to fade. But then, months later, the slower-moving debris from the explosion itself finally catches up and collides with that same circumstellar shell from behind, creating a second, delayed shockwave and a renewed burst of light. It is a natural echo, a cosmic boom heard twice. Another possibility is an even more exotic stellar corpse. This could have been a pair of white dwarfs in a tight dance, where one star explosively strips material from the other, leading to a first unstable flare, followed by the final, total merger and detonation of the second. The staggered brightening would be the signature of this two-step cosmic annihilation. Yet the clean, distinct separation between the peaks gives one pause. It feels less like a chaotic collision and more like a sequence, a procedure. This is where the natural story meets a staggering alternative. What if the delay was not caused by a shell of gas but by an intervention? Consider the concept of a failed supernova. A star destined to explode is a titanic reservoir of energy. A civilization capable of stellar engineering might see it not as a threat but as a power plant on the verge of a catastrophic meltdown. Could they attempt to stabilize it? Imagine vast, invisible fields or structures deployed to contain the collapsing core, to siphon off the furious energy in a controlled manner over time. The first peak of light might represent their failure to fully contain the initial collapse, a breach in their systems. The following months are not a quiet fade, but a period of frantic, titanic effort as they struggle to manage the runaway reaction. The second peak, then, is not a natural echo, but the final, catastrophic failure of their containment, the moment the star truly wins its freedom in death. An even more direct idea involves not containment, but consumption. Picture a star being mined, not for surface hydrogen, but for the dense, precious elements forged in its core: iron, nickel, gold, platinum. A process of stellar mining on this scale would involve delicately, impossibly, removing material from the star's heart. This could destabilize the intricate balance between the outward pressure of fusion and the inward crush of gravity. The star might begin to collapse, triggering the first explosive peak as its structure groans under the strain. The mining operation halts, and for a time, the star's remaining structure holds, leading to the observed fading. But the damage is done. Months later, the compromised core finally gives way completely, leading to the second terminal collapse and the final bright peak. In this scenario, the supernova is not a natural death, but an industrial accident of cosmic proportions. The light curve becomes a forensic report. The first peak is the moment the support beam is cut. The fading is the structure trembling. The second peak is the final, inevitable collapse. We are left with the light of a star that died twice. Was it a star wrapped in its own funeral shroud, its death echoing off its past, or was it a star that was worked on, a project that began with the dream of harnessing a sun and ended with the oldest story in the universe, that some forces, no matter how advanced your tools, remain forever wild? A star that dies twice speaks of immense, contained energy, but some particles from Andromeda suggest a force that was never meant to be contained at all. For over a century, one of the great unfulfilled quests in physics has been the search for a magnetic monopole. Every magnet we have ever found, from a simple refrigerator magnet to the Earth itself, has two poles, a north and a south. Cut a magnet in half, and you do not get a separate north and a south piece. You get two smaller magnets, each with its own pair of poles. The equations of physics, however, suggest that particles with just a single magnetic pole should exist. A magnetic monopole would be a fundamental particle that is pure north or pure south, a solitary point of magnetic charge. Finding one would be a discovery on par with confirming the existence of the electron or the Higgs boson, rewriting textbooks and unlocking new understandings of the forces that stitch the universe together. For decades, experiments have searched and found nothing. Then, from the general direction of the Andromeda Galaxy, our most sensitive detectors began picking up something strange. Not light or radio waves, but ultra-high-energy cosmic rays, particles screaming across the intergalactic void with energies millions of times greater than anything our most powerful particle accelerators can produce. A few of these events carried a peculiar signature in the cascade of secondary particles they created upon hitting our atmosphere. The patterns bore a haunting, though not definitive, resemblance to what theorists predict a magnetic monopole might produce. These candidate events are whispers, not confirmations, but they originate from a single patch of sky, a direction where Andromeda hangs. So the question becomes, what in that galaxy could possibly be creating such things? The natural explanations are cataclysmic. One possibility involves the theoretical decay of a false vacuum. This is a staggeringly complex idea, but imagine the very fabric of space as existing in a stable, but not perfectly stable state. A titanic event, like the merger of two supermassive black holes or a phase transition in the early universe, could create a bubble where space itself decays into a more stable form. The boundary of this expanding bubble would be a wall of inconceivable energy, a cosmic shockwave where the laws of physics briefly change. Such an event could forge particles that cannot exist in our current stable vacuum, including magnetic monopoles, and fling them outward like shrapnel from a grenade of reality itself. Another natural source could be the cores of hypermagnetized neutron stars, known as magnetars. Their magnetic fields are so intense they can twist the quantum vacuum around them, potentially spitting out exotic particles in rare, violent starquakes. If a magnetar in Andromeda experienced a catastrophic rupture, it could, in theory, be the gun that fired these ultra-high-energy bullets toward our galaxy. Both ideas are rooted in extreme, frontier astrophysics, yet the directed nature of the signals and their specific, rare character open another door. Could the monopoles be not a natural byproduct but a manufactured product for a civilization that has mastered physics to the point of manipulating fundamental forces? Magnetic monopoles would be a potential treasure. Their properties are theorized to be extraordinary. Some models suggest they could catalyze proton decay, a process that unlocks the binding energy within ordinary matter with nearly 100% efficiency. This is the ultimate power source, turning any lump of rock or cup of water into a reactor of unimaginable yield. A culture that learned to produce and contain monopoles would have solved energy forever. The occasional high-energy particle we detect could be leakage, a bit of fallout from their industrial processes or power plants, escaping containment and traveling across the galactic gulf. An even more staggering application is for propulsion. The theoretical interaction between a magnetic monopole and a cosmic magnetic field could be used for acceleration. A spacecraft equipped with a source of monopoles could, in essence, push against the galaxy's own magnetic field lines, achieving velocities approaching light speed without needing to carry reaction mass. The candidate events we see might then be the exhaust, the spent monopoles discarded or leaked from engines on an interstellar scale. We are left with a profound puzzle written in particles too small to see. Are these ultra-high-energy messengers the fallout from a natural cataclysm so vast it briefly altered the laws of physics in a corner of Andromeda? Or are they the microscopic signature of a technology that has learned to mine the deepest rules of reality for power and motion, their occasional misfires illuminating a path to capabilities we can only dream of? The detectors continue to listen, waiting for the next particle that might carry a single magnetic pole, and with it, a revolution in physics or a glimpse of an engine that moves galaxies. While magnetic monopoles hint at fundamental forces being harnessed, a different kind of signal arrives with clockwork regularity. From a quiet, unremarkable corner of the Andromeda Galaxy, a millisecond-long blast of radio waves erupts, fades, and then returns. This is a repeating fast radio burst, one of the few ever detected outside our own Milky Way. Fast radio bursts, or FRBs, are among the most energetic and puzzling phenomena in modern astronomy. In a fraction of a second, a single burst can release more energy than our Sun puts out in 80 years, a staggering flash that screams across the cosmos. Most are one-off events, a solitary crack of cosmic lightning that never repeats, making them nearly impossible to study. But this source in Andromeda is different. It comes back, its location adds to the intrigue. It is not in a turbulent star-forming nebula, not near a violent supernova remnant, and not at the heart of a chaotic galactic core. It sits in a quiet, mature region of the galaxy, a peaceful stellar neighborhood where such titanic explosions seem profoundly out of place. The environment offers no obvious natural engine for such ferocious, repeating energy. The leading natural theories for FRBs are as extreme as the bursts themselves. One points to magnetars, neutron stars with magnetic fields a quadrillion times stronger than Earth. A starquake on such an object could rip its crust, releasing a catastrophic wave of energy that lights up the radio spectrum. Another involves the collision of incredibly dense objects like neutron stars or black holes, a merger so violent it sends a final, brilliant shout across the wavelengths. Yet, the repeating nature of this Andromeda source challenges these cataclysmic explanations. You do not have a starquake or a stellar collision, and then have another identical one in the same spot weeks or months later. Repetition implies a source that survives its own outburst, a machine that can fire again and again. This is where the line between natural phenomenon and potential artifact becomes tantalizingly thin. If this repeating FRB is artificial, its presence in our closest galactic neighbor takes on profound significance. A civilization capable of generating such focused, interstellar strength radio pulses would likely use them for one of two grand purposes. The first is communication. A repeating beacon, especially one placed in a quiet region for clarity, is a perfect lighthouse. Its pattern could be a carrier wave, a simple "we are here" signal meant to be noticed by any developing technological society that learns to listen to the radio sky. The repetition allows for study, for confirmation, for the listener to be sure it is not random noise. The second purpose is propulsion. Theoretical models for interstellar light sails, vast mirrors pushed by laser beams, suggest that an ultra-powerful, focused radio burst could serve the same function, providing a concentrated push to a spacecraft across immense distances. A repeating FRB could be the engine pulse of a massive vessel, or a power transmission beam for a distant outpost, switching on periodically as needed. Astronomers are now engaged in a meticulous digital hunt, treating the bursts not just as astrophysical events, but as potential signals. Every repetition is recorded with exquisite precision, its arrival time, frequency, and polarization analyzed by supercomputers searching for any hint of pattern or modulation buried within the blast. They are looking for anything that breaks pure randomness, a numerical sequence in the timing, a subtle shift in frequency that carries information, or a polarization twist that suggests engineered control. The quiet region from which it broadcasts makes the search clearer, free from the radio chatter of stellar nurseries or black hole jets. So far, the bursts have resisted decoding. They appear sporadic, yet their very return makes them feel intentional. Is this the natural heartbeat of a previously unknown type of cosmic object, a magnetar with a uniquely stable and violent hiccup? Or is it a focused transmission from a point in Andromeda, a periodic flash in the dark saying, "Listen," waiting for the day we are advanced enough or curious enough to understand what comes after the hello? The search for a home does not end with planets. A gas giant in Andromeda, catalogued as M31GJ4, moves with a subtle, rhythmic wobble. This gravitational dance reveals the presence of an immense companion, not another star but a moon of staggering scale. The data paints a clear picture, a world larger than Mars, perhaps even rivaling Earth in size, locked in orbit around its colossal parent planet. This in itself is a monumental discovery, as exomoons are notoriously difficult to detect across such distances. But the real wonder lies in the spectroscopic whispers gathered as this giant moon passes behind its planet. The starlight filtering through its edges shows the unmistakable signs of atmospheric gases, likely nitrogen, with traces of water vapor and methane. This is not a barren rock. It is an exomoon with a thick, substantial atmosphere, a rarity that redefines our understanding of where life could thrive. Consider the vista from its surface. The sky would be dominated by the vast, banded sphere of the gas giant, hanging like a striped jewel, reflecting the distant sun's light in a perpetual, gentle twilight. This reflected light, known as planet shine, could provide enough warmth to maintain liquid oceans on the moon's surface, especially if coupled with internal heat from tidal forces, the same gravitational friction that keeps Jupiter's moon eovolcanic. Here, the tides would not just be in the water, but in the very rock, potentially driving a geologically active world with continents, mountain ranges, and deep seas. It is a place with two sources of energy, the faint, distant star and the radiant, immense planet it circles. This combination makes it a prime candidate for a habitable world, an oasis clinging to a giant. The implications are profound. In our own solar system, moons like Europa and Enceladus harbor subsurface oceans, but they are locked under miles of ice. This Andromedan moon offers something more familiar and yet alien: open skies and possibly open water. The presence of methane, which can be a biological byproduct, adds another layer of tantalizing possibility. Could its seas be rich with chemistry that has crossed the threshold into life? Future telescopes with optics powerful enough to analyze the atmospheric composition in finer detail will hunt for biosignature gases like oxygen in complex imbalance with methane. But they will also look for something else, a signature that would change everything. They will scan the moon's night side, the hemisphere turned away from its star, bathed only in the soft glow of planet shine. And there they will search for pinpricks of light that cluster in geometric patterns, lights that do not flicker like aurorae or volcanoes, but burn with a steady, localized intensity. The dream, the ultimate test, is to find not just the chemistry of life, but the lights of a civilization that has looked up at its giant planet for millennia and wondered about the distant galaxy we call home. The silent, sleeping giant at Andromeda's heart was not always so peaceful. While its central black hole slumbers today, radio telescopes have mapped a ghost in the machine, a fossil imprint of unimaginable violence. Stretching out from the galactic core are the faint, fading remnants of a relativistic jet, a beam of plasma and radiation that once screamed into the void at nearly the speed of light. Such jets are the universe's ultimate blowtorches, launched from the poles of feeding supermassive black holes, capable of carving through interstellar gas for hundreds of thousands of light years. They are typically arrow-straight, piercing the darkness like a cosmic spear, but the fossil jet in Andromeda is broken. At a point light years from the core, the ancient stream of energy makes a sudden, sharp turn. It kinks at almost a perfect right angle before continuing on its altered path, as if it struck an invisible wall and was deflected. Bending such a force of nature requires forces that dwarf our comprehension. A relativistic jet is not a gentle beam of light. It is a torrent of matter moving so fast its particles become effectively massless, guided and focused by magnetic fields of incomprehensible strength. To deflect it, you would need to apply a pressure greater than the jet's own immense momentum. In nature, this could only happen through a collision with something of staggering density and scale. One possibility is a previously unknown, incredibly dense cloud of molecular gas, a cosmic mountain that stood in the jet's path for an eon. The impact would have been titanic, a continuous explosion lasting for centuries as the jet poured its fury into the cloud, slowly boring through and being shoved off course. Another idea involves a second, smaller black hole passing through the jet's path, its intense gravity warping spacetime enough to act as a lens, bending the stream of particles around it like water flowing around a stone in a river. Both are natural explanations that push the limits of known astrophysics, requiring a perfect and rare alignment of monstrous objects. Yet the sharp, clean geometry of the kink gives one pause. It feels less like a chaotic collision and more like a precise deflection. This leads to a staggering and humbling line of thought. Could the bend be the signature not of a natural obstacle but of a shield? Imagine a civilization that has ascended to the galactic stage, building its wonders across the spiral arms. They would face cosmic threats far beyond asteroids or supernova. The greatest danger might come from their own galactic core, if the sleeping giant there were to awaken and unleash a relativistic jet. Such a jet would sterilize everything in its path, scouring star systems clean across a swath of the galaxy. For a culture that thinks in millennia, this is not a distant possibility, but an inevitable future catastrophe to be planned for. Their solution would need to be a project of godlike scale. They might construct a barrier not of metal or rock, but of focused gravity or contained energy, a wall placed light years from the black hole in the precise path a future jet would take. When the jet finally erupted, it would strike this engineered deflector. The collision would be a spectacle of unleashed energies, but the shield would hold, channeling the deadly beam away from inhabited regions of the galaxy, bending it harmlessly into the empty intergalactic void. The sharp kink we see today would be the permanent scar of that intervention, the fossilized proof that something once stood in the way of the galaxy's most powerful force and won. The implications are quiet and profound. We look at the bent jet and see a puzzle of astrophysics, but we might also be looking at the ultimate act of planetary defense, scaled up to protect not a city or a world, but an entire galactic civilization. It is either a monument to a freak cosmic collision or a permanent monument to foresight, a message carved in relativistic fire that says, here, something valued its future enough to build a wall against a star's death scream. The laws of physics are supposed to be the same everywhere, a universal rulebook written into the cosmos. But light traveling from quasars far behind Andromeda carries a whisper that threatens to tear a page from that book. As these ancient beams pass through the galaxy's vast, diffuse halo, astronomers have detected a minuscule but persistent anomaly. The fine structure constant, known simply as alpha, appears to shift. This is not a casual discovery. Alpha is a fundamental number, a precise combination of other constants that governs the strength of the electromagnetic force. It dictates how tightly electrons bind to atomic nuclei, how chemical reactions proceed, and how light interacts with matter. If alpha were different by even a few percent, stars could not burn, molecules could not form, and the universe as we know it would be impossible. Its constancy is the bedrock of reality, yet the data, gathered over years of painstaking observation with the world's most powerful telescopes, suggests that in the halo of Andromeda, alpha might be ever so slightly smaller. The effect is tiny, a variation of just a few parts in a million, but in the world of fundamental physics, that is a seismic tremor. The immediate and overwhelming scientific response is to search for error. Could it be an artifact of the instruments, a subtle miscalibration in the spectrographs that dissect the quasar light? Teams have checked and rechecked. Could it be an unknown effect from the interstellar medium within our own Milky Way, contaminating the signal? Models have been run and discarded. Each time, the anomaly remains, stubbornly linked to the path the light takes through Andromeda's outskirts. This points to a local phenomenon, something about that specific volume of space that is altering the very rules of electromagnetism for anything passing through. One natural explanation ventures into speculative cosmology. Some theories suggest that fundamental constants might not be perfectly constant after all, but could vary slightly across the vastness of space or over cosmic time, perhaps due to the influence of unseen extra dimensions. Andromeda's halo, with its unique history and composition, could be a region where this variation becomes faintly detectable. It would be a natural, if revolutionary, feature of the universe's architecture. But the localization of the effect to a galactic halo, a specific structure, invites a more staggering possibility. What if the variation is not natural, but the residual signature of a field? Not a magnetic or gravitational field, but something more fundamental, a field that interacts with the fabric of spacetime and the constants woven into it. For a civilization that has progressed beyond harnessing energy and begun to manipulate the underlying rules of reality, establishing such a field could be the ultimate achievement. Imagine the purpose, a stable, galaxy-scale field that subtly lowers the fine structure constant could serve as a regulator or a shield. In regions where alpha is lower, atomic bonds are very slightly weaker and nuclear reactions proceed at a different pace. This could be a method of stellar husbandry on a galactic scale, a way to gently temper the fusion rates in stars, extending their lifespans by billions of years to ensure a stable energy supply for eons. Alternatively, such a field could be a side effect of something else entirely, the operational footprint of a technology that warps spacetime for travel or communication. The theoretical engines for a warp drive or a stable wormhole would require manipulating spacetime in profound ways. potentially creating localized distortions in the fundamental constants as a byproduct, like the wake of a ship altering the water it passes through. The halo of Andromeda, then, would not just be a cloud of dark matter and stray stars. It would be permeated by the faint, lingering echo of a completed project, a permanent adjustment to the local laws of physics made long ago for reasons we can barely fathom. The light from distant quasars is our probe, bending through this altered space and revealing the imprint of a hand that did not just build with matter, but rewrote the rules themselves. Is this tiny variation a crack in the foundation of physics, a clue that the universe's rulebook has marginal notes we are only now seeing? Or is it the signature of a culture that graduated from building worlds to tuning the fundamental forces that create them? The quasar light holds the answer, a secret encoded in the precise spacing of spectral lines, waiting for us to learn how to read it. The universe bends light and warps constants, but sometimes its artistry is displayed in pure, cold geometry. Orbiting a cool, distant star in Andromeda is an ice giant, a world of deep blue methane and slushy water ice mantles. Such worlds are common. What sets this one apart is its crown. Encircling the planet is a ring system of breathtaking complexity and impossible brilliance. It is not a single, faint band like Saturn's. This is a vast disk composed of dozens upon dozens of distinct, razor-sharp rings, each separated by a gap of perfect darkness like grooves on a cosmic record. The rings themselves are made of water ice, but they are brighter and more reflective than any natural ice should be, glittering with an almost metallic sheen that catches the faint starlight and throws it back into space with startling efficiency. In our own solar system, we understand how such intricate ring structures can form and persist. The key is gravity's delicate balance maintained by shepherd moons. These are small moons that orbit just inside or outside a ring's edge. Their gravitational influence acts like a cosmic comb, herding the ring particles, keeping the edges sharp and preventing the disk from spreading out and dissipating over time. It is a beautiful, natural ballet, yet the perfection of this Andromedan ring system gives astronomers pause. The number of distinct rings is statistically bizarre. Their edges are preternaturally sharp, and their reflective brightness suggests ice of a purity that seems manufactured, not formed from the random collisions of comets and asteroids. This level of complexity and order hints at something beyond natural shepherding. It feels engineered. This leads to a staggering possibility. What if the rings are not a natural formation at all, but a construction? Imagine a civilization that looks at its dim, distant sun and realizes it needs more energy. An ice giant with its vast reservoir of frozen water presents a perfect resource. They could dismantle its moons, process the ice into trillions of pristine, mirror-like panels, and place them into precise, stable orbits around the planet. The resulting ring system would be a solar power collection array on a planetary scale. Each ring could be angled to reflect and focus the faint starlight toward a central collector station or a swarm of receiving satellites, harvesting energy from every angle. The distinct gaps would be necessary maintenance lanes or the result of resonant orbits designed for maximum efficiency. Alternatively, consider the rings as a form of cosmic infrastructure. Those glittering, icy particles could be more than mirrors. They could be individual nodes in a vast, decentralized communication network. Each piece of ice, perhaps coated with a reflective metamaterial, could serve as a passive relay, bouncing laser or maser signals across the star system with minimal loss. The entire ring system becomes a galaxy-wide internet hub, a permanent, stable network for data transmission between planets, moons, and spacecraft, its complexity reflecting the traffic it handles. The most poetic theory, however, sees the rings not as a tool but as a testament. What if they are art? A culture that has mastered its environment might turn its attention to creation for creation's sake. To sculpt the rings of a gas giant, to arrange billions of glittering fragments into a precise, beautiful pattern visible from neighboring star systems, would be a monument of unimaginable scale. It would be a statement that says we were here and we found beauty in the laws of physics and we used them to make this. It is astronomical art, a sculpture writ across the sky of an entire world, meant not for utility but for wonder, a beacon of pure aesthetics in the dark. So we are left gazing at a cold, blue world wrapped in a dazzling belt of light. Is it the most spectacularly shepherded ring system in the cosmos, a natural masterpiece of orbital mechanics? Or is it a power grid, a communication network, or a gallery piece, demonstrating that once a civilization learns to build, its canvas eventually becomes the sky itself? This glittering ring system speaks of order and reflection, but a fountain of pure annihilation flows from the galaxy's dark heart. Deep within the gamma-ray sky of Andromeda, a faint, persistent thread has been traced. It is not a filament of gas or a beam of light, but a stream of antimatter particles flowing outward from a region near the galactic core. Antimatter is the universe's perfect opposite. For every type of ordinary matter particle, there exists an antimatter twin with opposite charge. When matter and antimatter meet, they annihilate each other in a flash of pure energy, a conversion 100% efficient. In our universe, matter overwhelmingly dominates. Antimatter is exceedingly rare and difficult to contain. To find it flowing in a collimated stream like water from a fountain is deeply strange. The natural production of antimatter is a violent business. It can happen in the furious accretion disks around black holes or in the intense magnetic fields of pulsars, where particle collisions are so energetic they can spontaneously create matter-antimatter pairs. Some of that antimatter can escape, but it should spray out in all directions, a diffuse cloud, not a focused jet. The fact that this stream is so well-defined, so channeled, suggests something is directing the flow. This is where the natural explanation begins to strain. Could an unseen object, like a rapidly spinning neutron star with a uniquely powerful and narrow magnetic field, be acting as a cosmic particle accelerator, focusing the antimatter into this slender beam? Possibly, but no such object has been identified at the fountain source. The region is suspiciously quiet in other wavelengths, offering no obvious engine for such a precise phenomenon. This quiet precision opens the door to a staggering possibility. What if the fountain is not a natural wonder, but the signature of an industry? Antimatter is the ultimate rocket fuel. In theory, a matter-antimatter engine would provide the most efficient propulsion conceivable, capable of accelerating a spacecraft to a significant fraction of light speed. The problem is production and storage. Creating antimatter in meaningful quantities requires phenomenal energy, and containing it requires electromagnetic bottles of incredible precision, as a single touch with the walls of a normal container would trigger instant annihilation. The faint gamma-ray stream we see could be a leak. Imagine a production facility, a vast complex near the galactic center where titanic energies are harnessed to manufacture antimatter, gram by precious gram, for use in starship engines or as a compact power source for megastructures. Even with the most advanced containment, there would be losses. A few antiprotons or positrons escaping the magnetic bottles, streaming out into space where they eventually meet stray atoms and annihilate, creating the faint, persistent gamma-ray glow we detect. The fountain would be the facility's exhaust, the unavoidable signature of an unimaginably advanced technology going about its business. There is an even more deliberate interpretation. Perhaps the stream is not a leak but a deliberate venting. After antimatter is produced, it might need to be purified, or the containment systems might require periodic flushing. They could be deliberately channeling waste or lower quality antimatter away from the facility in a controlled jet, safely disposing of it into the void. The fountain would then be a cosmic smokestack, a managed release of the most dangerous substance in the universe. We are left observing a thread of annihilation hanging in the dark. Is it the natural byproduct of a celestial particle accelerator we have yet to find, a rare and beautiful quirk of physics? Or is it the telltale glow from the universe's most potent fuel refinery, a sign that somewhere in Andromeda, engines are being filled for journeys across stars? A star that refuses to die presents a different kind of cosmic defiance. In a dense region of one of Andromeda's spiral arms, a massive star once staged a brilliant, convincing death. Centuries ago, from our perspective, it erupted in a titanic explosion known as a supernova imposter event. It brightened by millions of times, ejecting a shell of material that should have been its final farewell. In a true supernova, the star's core collapses irrevocably, leaving behind a neutron star or black hole and scattering the rest into a nebula. This star did not. It survived, the great eruption faded, and the star, though battered and diminished, remained shining at its core. It was a cosmic actor playing a death scene, only to take a bow and walk offstage. For a long time, astronomers catalogued it as a fascinating oddity, a stellar Lazarus that had narrowly escaped its own doom. Then the new data arrived. Modern observatories monitoring the star's long-term behavior detected something profoundly strange. The star was now exhibiting intense, cyclical magnetic activity and spot patterns that bore no resemblance to its pre-eruption self or to any other known giant star. Its surface seemed to be convulsing with magnetic storms on a regular, predictable schedule, but the physics of those storms did not match standard models for stellar interiors. It was as if the star's internal dynamo, the engine that generates its magnetic field, had been completely rewired. This is the central mystery of the zombie star. A natural supernova imposter event is thought to occur when a massive star becomes so unstable that it violently ejects its outer layers, but the core remains intact enough to avoid total collapse. It is a stellar tantrum of epic proportions. The star should then settle into a new, quieter phase of life, perhaps as a stripped-down, hotter star known as a Wolf-Rayet star. But it should not develop a bizarre, new magnetic personality billions of years into its life. That shift in fundamental behavior is what defies easy explanation. One compelling natural theory involves a hidden companion. Perhaps the eruption was triggered by the star consuming a nearby planet or a smaller stellar partner. The ingested material could have churned the star's interior in a unique way, altering the flow of plasma in its depths and permanently changing how its magnetic field is generated. The cyclical spots could be the long-term echo of that cosmic digestion, a stellar indigestion that never truly settled. Yet the precision and strangeness of the cycles give pause. They are too orderly, too distinct from any known stellar recovery. This leads to a more staggering line of thought. What if the star's survival was not a natural near miss but a managed rescue? Imagine the star as it was, destined for a true, cataclysmic supernova that would have sterilized the planetary systems for light years around. A civilization residing in those systems would face an existential deadline. Their solution would not be to flee, but to fix the problem at its source, using technologies that manipulate gravity or energy on a stellar scale. They might have intervened in the star's final death throes. They could not stop the eruption entirely. The built-up pressure was too great, but they could attempt to vent it in a controlled manner, to stabilize the collapsing core and prevent the final, terminal implosion. The process would be akin to performing emergency surgery on a thermonuclear bomb as it explodes. The intense magnetic activity and spot cycles we see today might not be natural at all. They could be the operational signature of that stabilization technology still at work. The cyclical spots could be the visible manifestation of internal dampeners or containment fields, pulsing as they regulate the star's newfound equilibrium, a permanent life support system for a star that was meant to die. The star's strange new heartbeat would be the rhythm of the machine keeping it alive. Alternatively, consider a darker purpose. What if the star was not saved but repurposed? The eruption cleared away the outer layers, leaving a more exposed, energetic core. This could have been the goal all along, not to preserve a home sun, but to create a more efficient engine. A civilization might deliberately trigger such an eruption to strip a star down to a state where its energy is easier to harness or its magnetic field more useful for galactic-scale power transmission or communication. The odd magnetic cycles could be a side effect of that engineering, the star now functioning as a tuned component in a vast, invisible machine, its periodic spots marking the transfer of energy or data. We are left observing a star that cheated death and awoke with a new, inexplicable pulse. Is it a natural survivor with a uniquely scrambled interior, a one-in-a-billion testament to stellar resilience? Or is it a monument to a technology that learned not just to build with stars, but to heal them, to take a dying sun and grant it a second, stranger life, forever bound to the machinery that sustains it? The light from this zombie star carries the story of a death that failed and a rebirth that may not have been its own. A bubble of perfect nothing hangs in the dusty spiral arm. This is the dustless zone, a spherical void hundreds of light-years wide where the interstellar medium has been scrubbed clean. Surrounding it is the normal, murky stuff of a galaxy, great clouds of fine silicate and carbon grains, the raw material for future stars and planets. But inside this zone, there is only a near-perfect vacuum, an emptiness so profound it allows astronomers to see distant galaxies behind Andromeda with startling clarity, as if looking through a perfectly clean window. Such cleanliness defies the natural state of a spiral arm, which is a chaotic, dusty workshop. The first question is, what kind of cosmic janitor could have done this? The natural tools are powerful but messy. Stellar winds from massive young stars can blow bubbles in the dust, carving out cavities. A supernova explosion can sweep a region clean with a titanic shockwave. But these processes are violent and leave evidence. The stars that did the cleaning are usually still there, blazing away at the center of the bubble, or the remnant of the explosion is visible as an expanding shell of hot gas. In the dustless zone, there is no central cluster of brilliant young stars. There is no supernova remnant pulsating with energy. The void is centered on nothing in particular, a sphere of absence with no obvious engine at its heart. Furthermore, natural bubbles are rarely this geometrically perfect or this persistently clean. Over millions of years, the diffused gas and dust from the surrounding arm should have begun to seep back in, fogging the window. Yet this zone remains pristine, its boundaries sharp. This level of order in a region known for chaos invites a more deliberate explanation. Imagine the challenge of navigating or communicating across interstellar distances. Dust is more than just a cosmetic fog. It scatters light, absorbs radiation, and poses a physical hazard to anything traveling at high speeds. For a civilization operating on a galactic scale, dust is cosmic smog, obscuring the view and clogging the lane. What if they decided to clear it? The dustless zone could be a deliberate construction, a swept volume of space maintained for a specific purpose. One possibility is that it is a clearway, a designated high-speed travel corridor. Just as ancient seafarers needed clear, deep channels to sail their ships, a starfaring culture might need regions free of obstructive debris to allow for safer, faster transit between important points in the galaxy. The spherical shape could indicate a hub, a central clearing where multiple routes converge, kept dust-free by gentle, sustained technology, perhaps a network of forces that gently pushes any incoming dust grains out of the volume, maintaining the perfect vacuum. Another, more profound purpose could be observational. The clearest, most undistorted view of the universe beyond Andromeda would be from within such a zone. It would be the ideal location for a galactic observatory of unimaginable scale, a facility designed to peer into the deep universe without the dimming and reddening effect of interstellar dust. The entire spherical volume might be a lens, a controlled environment to focus and study the light from the earliest galaxies, a project dedicated not to looking inward at its own galaxy, but outward at the cosmos. The silence from within the zone is its most telling feature. Our telescopes see straight through it, finding only distant, faint galaxies in the background. But in that emptiness, there might be structures that do not emit or reflect light, things that are simply part of the scaffolding that keeps the void clear. We are left looking at a hole in the galactic tapestry. Is it the faded scar of a series of ancient supernovae, a natural wonder of coordinated stellar winds that have long since died away? Or is it a maintained space, a testament to a culture that values clear lines of sight and open roads, a permanent clearing in the cosmic forest made not by fire but by will? Two worlds hang together in a perpetual dance, bound not to a star but to each other. In a quiet system within Andromeda, astronomers have confirmed the existence of a true binary planet. This is not a star with two worlds in separate orbits, but a pair of Earth-sized planets locked in a mutual gravitational embrace, orbiting a common center of mass between them, while together they trace a wide, stable path around their sun. The dynamical challenges of such a system forming naturally are immense. In the chaotic early days of a solar system, protoplanets collide and merge to form larger worlds. For two planet-sized bodies to avoid that final merger, to instead settle into a stable, balanced waltz around each other, requires a series of gravitational nudges of near impossible precision. It is like rolling two marbles down a hill and having them come to rest perfectly, spinning around one another without touching. The most likely natural explanation is a glancing, off-center collision between two forming protoplanets. Instead of coalescing or shattering, they could have been sent into a graze that imparted just the right spin and velocity to enter a mutual orbit, a cosmic billiard shot of breathtaking luck. Yet the stability of their current dance, enduring for billions of years, feels like a statistical miracle. From the surface of either world, the vista would redefine the concept of a sky. The sister planet would dominate the heavens, a vast marbled sphere hanging motionless in the same spot, its phases cycling from a thin crescent to a glorious full world, casting a soft secondary light at night. Tides would be a complex symphony, pulled not just by a distant moon, but by an entire neighboring world, creating gentle, global swells in oceans and perhaps even in the solid crust itself. The day-night cycle would be intertwined with the binary orbit, creating periods where the two worlds eclipse each other, plunging one hemisphere into a sudden, profound twilight beneath the shadow of its twin. This permanent, intimate proximity makes the question of life and intelligence irresistible. Could life arise on one or even both? The exchange of material through meteorite impacts is a proven concept. Rocks blasted from one world by asteroid strikes could easily travel the short gap and seed the other with microbial life. We could be looking at a single biosphere spread across two planets, but the truly captivating thought is of a civilization that evolved under that constant, looming presence. For them, the greatest philosophical and scientific question would be answered from birth. We are not alone. Another world with its own continents, clouds, and perhaps even lights is right there. The drive to cross that gap would be an intrinsic part of their cultural DNA, not a distant dream but the obvious next step. Their space age might begin not with orbiting their own planet, but with launching a probe directly toward the world that forever fills their sky. Colonization would be a given, not an expedition to a hostile, distant rock, but a migration to a new frontier visible to the naked eye. Imagine the societal structure that could emerge. Two planets close enough for relatively easy travel, yet distinct environments evolving separately. They could develop a profound partnership, a constant exchange of ideas, resources, and culture. One world might specialize in oceanic industries, the other in mineral-rich mountain ranges. They would share a single sun but have two political bodies, perhaps cooperating in a permanent alliance or competing in a friendly, constant rivalry that drives technological progress at an incredible rate. Their greatest achievements might be the bridges they build, not metaphorically, but literally theoretical concepts for orbital rings or space elevators that physically link the two worlds, turning the binary system into a single, interconnected civilization. The binary planet is more than a dynamical puzzle. It is a test case for a universe where the step into the cosmic community is not a leap into the unknown, but a short hop to a neighbor's house permanently visible in the evening sky. Death is not always the end of a world. Sometimes it is a transformation into a new and more dangerous kind of home. Orbiting the furious corpse of a dead star is a planet that should not exist. The star is a gamma-ray pulsar spinning dozens of times per second, lashing its surroundings with twin beams of the most lethal radiation in the universe. These are not the gentle radio pulses we have discussed before. These are scythes of gamma rays capable of stripping atmospheres and sterilizing rock. Yet the transit data is clear. A small, rocky world not much larger than Earth passes regularly in front of this cosmic lighthouse. Its orbit places it in a region where, by any normal logic, it should have been vaporized eons ago. The calculations reveal something even more bizarre. The tiny amount of stellar heat it receives from the cold, dead pulsar is negligible, but the planet is warm. Its equilibrium temperature, deduced from infrared observations, is surprisingly temperate, even comfortable. The only possible source for that warmth is the pulsar's own furious radiation. The planet is not in a traditional habitable zone defined by starlight. It is in a radiation bath, heated from within by the constant, deadly gamma-ray bombardment. This presents a paradox of cosmic proportions. For life as we know it, this environment is the definition of hell. The surface would be bathed in a perpetual, planet-killing glare, a downpour of particles that would shatter complex molecules and rip apart DNA in an instant. An atmosphere would be blasted away, and the ground itself would likely be a barren, irradiated slag. The very idea of life here seems not just implausible but laughably impossible. Unless the planet possesses a defense of unimaginable scale, the first natural possibility is a magnetic field of staggering strength. Earth's magnetic field protects us from the solar wind, a gentle breeze compared to a pulsar's hurricane. To deflect gamma rays and relativistic particles, this world would need a magnetic shield millions of times more powerful, a planetary force field generated by a molten core churning with ferocious intensity. The internal dynamo required would be unlike anything in our models, perhaps powered by immense tidal forces from the pulsar's gravity, kneading the planet's interior like dough. Such a world might have a shimmering, permanent aurora covering its entire sky, a visible manifestation of its titanic shield holding back the apocalypse. But the energy required to maintain such a field indefinitely pushes against the limits of planetary physics. This is where the natural story meets a far more compelling idea. What if the shield is not natural at all? Imagine a civilization that does not seek to destroy threats but to master them. A pulsar with its perfect, unwavering rhythm and titanic energy output is not a menace to be avoided but a resource of unimaginable value. Its beams are a constant, predictable, and incredibly powerful source of energy. The challenge is harvesting it. This planet, then, would not be a freak of nature. It would be a fortress, an outpost built for a singular, audacious purpose, to tap the pulsar directly. The entire world could be encased in an artificial magnetosphere, a technological shell generated by a planetary network of superconductors or contained singularities. The shield would not just defend, it would function as a collector, channeling the pulsar's gamma-ray fury into usable power. The temperate warmth we detect would not be a side effect, but the regulated output of this conversion process, waste heat from a civilization using a stellar corpse as its battery. Who would live in such a place? It would not be a home for a biological species like us. The environment, even with the shield, would be far too hazardous for fragile organic life. Instead, this could be a research station, a monitoring post, or a computational hub operated by artificial intelligence. Beings of pure energy or minds housed in durable synthetic forms could thrive where biology would perish in a microsecond. They would be the ultimate engineers, maintaining the shield, studying the pulsar's physics up close, and perhaps using its precise pulses as a galactic clock or a navigation beacon for a network spanning Andromeda. The planet becomes a watchtower on the edge of a perpetual storm, its inhabitants not hiding from the fury but leaning into it, drawing power from the heart of the tempest. We are left with a chilling and magnificent vision. Is this world a staggering natural anomaly, a diamond-hard planet born with a magnetic heart strong enough to stare down death? Or is it the ultimate engineering project, a fortress built not for defense against an enemy, but for conquest, the conquest of a star's final, most violent breath? The silent, rocky world continues its transit, a dark silhouette against the gamma-ray glare, keeping its secrets behind a wall of either impossible physics or unimaginable will. The fortress world, orbiting a gamma-ray pulsar, exists at one extreme of cosmic environments, but the seeds of life may be sown in a far gentler, more fertile place. Drifting through a spiral arm of Andromeda is a colossal nursery of gas and dust, a molecular cloud so vast it could birth 1,000 solar systems. When astronomers trained their spectrometers on this cloud, catalogued as M31MC1, they expected to see the simple chemical signatures of raw cosmic ingredients, hydrogen, carbon monoxide, and maybe a few basic organic compounds. What they found instead was a chemical symphony. The spectral lines revealed an astonishingly rich and diverse brew of complex organic molecules. These are not just the building blocks of life, they are the prefabricated rooms and hallways. The cloud contains substantial amounts of molecules like polycyclic aromatic hydrocarbons, which are intricate, carbon-rich structures resembling fragments of soot or graphene. It holds sugars like glycolaldehyde, the simplest sugar molecule, which can form the backbone of RNA. There are even tentative detections of amino acid precursors, the very compounds that link together to form proteins. In our own galaxy, we find such molecules in trace amounts in places like the Orion Nebula. But here, in this one Andromedan cloud, the concentration and variety are off the charts. It is not a sprinkle of seasoning, it is a thick, simmering broth of probiotic chemistry. The immediate question is how such a rich soup formed naturally. Molecular clouds are the chemical factories of the galaxy, where atoms stick together on the surfaces of dust grains to form ever more complex molecules. Intense radiation from nearby young stars can provide the energy to drive these reactions, forging order from chaos. This particular cloud sits in a region bathed in the ultraviolet light of several massive stellar nurseries, a perfect natural laboratory for advanced chemistry. It could be a cosmic coincidence, a perfect storm of density, temperature, and radiation that has turned this one cloud into a prolific organic reactor, churning out the ingredients for life at an industrial rate. It might be the universe's most productive bakery, where the flour, sugar, and eggs of existence are being mixed in staggering abundance. Yet, the sheer efficiency of this process gives one pause. Could natural physics alone achieve such a concentrated yield? This leads to a more profound and unsettling line of thought. What if the cloud is not a factory but a dump? Consider the ultimate fate of a biosphere. A civilization that spans stars will produce waste on a scale we can barely conceive, not just physical trash, but biological and chemical byproducts. When a world is deconstructed for a megastructure, or when an entire ecosystem is processed for its raw materials, what happens to the complex organic molecules? The proteins, the carbohydrates, the nucleic acids, They would be broken down but perhaps not completely destroyed. The resulting slurry of refined organics, the distilled essence of a once living world, would need to be disposed of. This molecular cloud, with its inexplicably high density of life's precursors, could be a designated repository. It would be the galactic equivalent of a compost heap on a cosmic scale, where the processed remains of forests, oceans, and perhaps even beings have been scattered, their complex chemistry slowly dissipating into the cold gas. The cloud is not creating life, it is recycling it. An even more deliberate possibility turns this idea inside out. What if the cloud is not a graveyard but a garden? A civilization that has mastered genetics and nanotechnology might not wait for life to arise on its own. They could seed the galaxy. This cloud, with its ideal conditions, could be a targeted nursery, deliberately enriched with a starter kit of advanced organic molecules to kickstart the process of biogenesis on any young planets that eventually form within it. They are not building life directly, but they are tilting the odds, pouring the foundation so that when planets condense from this material, they are already rich with the potential for biology. It is a project measured in billions of years, a patient act of cosmic husbandry. The molecules we detect would be the seeds scattered by a hand we cannot see, in the hope that somewhere in the distant future something will grow. So we observe this swirling dark cloud, its light hiding a chemical treasure trove. Is it a natural marvel, a testament to the universe's innate ability to cook up complexity in its dark, dusty kitchens? Or is it a silent monument to a cycle of life and use on a galactic scale, holding either the discarded ashes of a consumed biosphere or the carefully planted seeds for a future one? Its spectral lines tell us what is there, but the story of why it is so rich remains written in the dark between the molecules themselves. A solitary predator drifts through the starry lanes of the spiral arm. It is a stellar mass black hole, a dark heart perhaps 10 times heavier than our Sun, but it is not resting in some quiet corner of space. This object is on the move, carving a high-speed, inclined path through the galactic disk. As it travels, it feeds. Interstellar gas, drawn in by its immense gravity, spirals into an accretion disk of superheated plasma, flaring with X-rays and gamma rays that betray its passage. These are the hunger pangs of a cosmic hunter, a brilliant but deadly trail left across the darkness. The mystery is not its existence, but its location. This black hole is not in a dense star cluster, not near a supernova remnant, not in any region where massive stars are born and die violently. It is alone, far from any possible birthplace, a gunshot with no gun. How did it get there? The most elegant natural explanation is a story of cosmic violence and abandonment. Black holes are born in the collapse of massive stars, and such a cataclysm often gives the resulting corpse a powerful kick. If the supernova explosion is lopsided, it can send the newborn black hole rocketing out of its birth cluster like a bullet from a rifle, sentencing it to wander the galaxy alone. Alternatively, this could be a remnant of a disrupted binary system. Perhaps it once orbited a companion star, and a close encounter with a third star ripped that companion away, flinging the black hole onto this strange, solitary path. It is a gravitational orphan cast adrift by the chaotic dynamics of its youth, yet its clean, inclined orbit and the absence of any stellar family give one pause. Could this journey be more than an accident? Consider the black hole not as a menace but as a resource. For a civilization thinking on a galactic timescale, a stellar mass black hole is the ultimate battery. Its accretion disk is a constant, furious source of energy, and its intense gravity is a tool of unparalleled power. What if this black hole is not wandering but being guided? The concept is staggering, but the physics is conceivable. A sufficiently advanced culture might learn to manipulate gravity itself. They could construct a mobile containment system, a kind of gravitational harness, using the black hole's own energy to propel it. The flaring we see as it accretes gas might not be a sign of random feeding, but the controlled ignition of its engine, a pulsed drive that uses swallowed matter to provide thrust, slowly steering the dark giant across the galaxy. Its destination could be a construction site, a region where its immense gravity is needed as a stabilizer or a power source for a megastructure too large for a star to anchor. Even more compelling is the idea of a mobile habitat. Imagine a world or a fleet of worlds that does not orbit a star. Instead, it orbits this black hole. The black hole's accretion disk could provide light and heat, a miniature artificial sun powered by infalling matter. The civilization living within this system would be truly nomadic, carrying their own sun with them. They would not be tied to the lifespan of a star. They could mine asteroids and comets for fuel to feed the black hole, sustaining their miniature cosmos for eons. The black hole's high-speed journey through the galaxy would then be their voyage. They are not fleeing anything, they are exploring, or perhaps simply living a life of permanent migration, using the greatest engines in the universe as their sails. We are left watching a point of darkness punctuated by brilliant flares. Is it a natural relic, a piece of shrapnel from an ancient stellar war, now tumbling mindlessly through the void? Or is it the beating heart of a traveling kingdom, a dark sun at the center of a moving civilization, its path not random at all, but the slow, deliberate course of a people who have learned to make a home within the deepest well of gravity? The flares mark its passage, a trail of breadcrumbs written in X-rays, leading to an answer we can only guess at from an impossible distance. The final object is not a star, a planet, or a structure. It is an entire galaxy, or rather, it is the ghost of one, at the very edges of Andromeda, where its vast halo of stars thins into the intergalactic void. Astronomers have mapped a series of gravitational lensing distortions that defy conventional explanation. The light from galaxies far behind Andromeda is being bent and warped in a peculiar way. The distortions are too symmetric, too cleanly mirrored around Andromeda's own visible mass. It is as if the galaxy we see is casting a second, fainter gravitational shadow, a perfect duplicate of its own immense pull superimposed upon itself. This anomaly points toward one of the most speculative ideas in all of theoretical physics, the concept of mirror matter. The theory suggests that for every particle of ordinary matter that makes up our stars, our planets, and us, there could exist a twin, a mirror particle. These mirror particles would feel their own version of the forces of nature, a mirror version of electromagnetism and the nuclear forces, but they would be completely invisible and intangible to us. The only way they could interact with our familiar world is through the one universal force that touches everything, gravity. A mirror proton would pass right through an ordinary Earth as if it were not there, yet its mass would still pull on our planet with its own tiny gravitational tug. Now scale that idea up to a cosmic level. The symmetric gravitational distortions at Andromeda's edge could be the signature of an entire mirror galaxy, a dark twin made of this exotic matter, perfectly overlapping the Andromeda we see with light. It would have its own mirror stars burning with a physics we cannot see, and its own mirror planets orbiting in a parallel reality that shares the same space as our neighbor galaxy, separated by a fundamental law of the universe. The two galaxies, ordinary and mirror, would be woven together, their combined gravity dictating the motion of stars, yet one would remain forever hidden, a phantom limb of the cosmos. This leads to the ultimate, mind-bending question on our journey. If a mirror Andromeda exists, could it harbor life? Could a mirror civilization have evolved there, on worlds of mirror matter, under the light of mirror suns? They would have developed their own science, their own art, their own history, all unfolding in the same location as the brilliant spiral we observe, yet completely unaware of our existence as we are of theirs. We would feel each other's gravity, the silent, mutual pull of two entire civilizations occupying the same point in space and time, but separated by the deepest chasm imaginable, a chasm built into the very laws of reality. They could be building their own megastructures, having their own wars, sending their own signals, and we would never know. Their greatest monuments and their most catastrophic explosions would happen in perfect, ghostly silence right before our telescopes. It is a haunting and beautiful thought to end on. After exploring 40 strange objects from solitary sentinels to engineered stars, we arrive at the possibility that the greatest mystery of all is not a thing within Andromeda, but an entire other Andromeda itself. The search continues not just for lights in the dark, but for the subtle, symmetric pull of shadows that might tell us we are not alone, but that we are sharing our cosmic neighborhood with a universe we can never touch, see, or hear, only feel in the gentle, persistent bending of distant starlight. From the ghostly imprint of a mirror universe to the faint chemical whispers of life itself, our journey through 40 of Andromeda's strangest objects has been a voyage across the extremes of reality. We have stood before stars that sing and stars that cheat death, gazed upon rings that could be art or machinery, and traced the outlines of voids that might be cleared highways or cosmic graves. For every object, from the backward traveling star to the dark knot of invisible matter, science offers a plausible, natural explanation, a testament to the universe's boundless capacity for creating wonder through physics alone. Yet it is the slim, shimmering possibility of something more, the chance that a flicker of light or a bend in gravity might carry a signature of intelligence that truly ignites our spirit of exploration. This tension is not a flaw in our search, but its very engine. The pursuit of these mysteries, the relentless questioning of each anomaly, is what propels our understanding forward, stretching the limits of our imagination as far as the telescopes that guide it. And remember, this gallery of cosmic wonders is not a distant abstraction. Andromeda is our closest galactic neighbor, and it is on a direct, inevitable collision course with our own Milky Way. In a few billion years, these two great spirals will merge, and the objects we have pondered from afar, the potential megastructures, the rogue planets, the ancient stellar engines, will become part of our new combined galactic home. The mysteries of Andromeda will, quite literally, become the mysteries of our own backyard. So as you look up at the night sky, let your wonder roam. Which of these 40 strange objects captured your imagination the most? Was it the lonely, glowing rogue planet or the synchronized stellar fireworks? Share your thoughts in the comments below. If you enjoyed this deep dive into the cosmos, subscribe for more journeys to the edges of our understanding. The universe is vast, strange, and full of stories waiting to be told. All we have to do is keep looking